I go.
Should I look both ways before you cross me, baby? 'Cause I don't break for boys.
I'm moving on. Hey, hey, I'm moving on. Hey, got nothing left to say. Let's be on my way. Let's stop life. I'm moving on. Oh, I'm moving on. I got a new life. He runs for miles. 67 fastback. Oh, it's just my style. We're headed down the road. Just enjoy the show. Watch me as I go.
Should I look both ways before you cross me, baby? 'Cause I don't break for boys.
I'm moving on. Hey, hey, I'm moving on. Hey, got nothing left to say. Let's be on my way. Let's stop life. I'm moving on. Oh, I'm moving on. I'm moving on. I'm moving on. I'm moving on.
Welcome back. You're watching Formnext News, brought to you straight from the Frankfurt fairgrounds with the latest and upcoming stories from the world's leading exhibition on all things additive manufacturing and the next generation of industrial production. My name is Shristi Mangalpal, and these are today's top stories. The Formnext arena grows ever more dynamic, with exhibitor halls buzzing and curious visitors admiring the exhibits with awe. This calls for a quick recap and selected outlooks. Sprouting companies, SMEs and startups are now becoming serious employers and conquering the market with fresh ideas. That's why Formnext opened its doors to aspirants wanting to set foot in the industry. The Formnext Career Day at the AM4U area served as a portal for both job seekers and potential employers. Also on offer were complimentary career counseling, a free photo shoot and an extensive job wall. Next, Formnext played Cupid. The international matchmaking event served as a face-to-face meeting point for the next generation of intelligent industrial production. The event saw the entire AM process chain with all its technologies and applications being presented under one roof. Visitors could generate business contacts, gain market knowledge, and become acquainted with intelligent AM manufacturing solutions. Once again, the AM4U area brought core industry topics into prominence, such as a roundtable talk on sustainability, moderated by Frank Jablonski, featuring prominent industry stakeholders. Sherry Monroe, Executive Director, Additive Manufacturer Green Trade Association, AMGTA.
We talk about sustainability. We're not talking about something sort of off to the side that companies do if they have some extra time and some extra resources. From our perspective, what sustainability should look like is less energy consumption, less waste, less source material, shorter lead times, less inventory sitting on shelves, really those same strategic drivers every business is looking at anyway. And whether sustainability is the objective or if it's the fortunate unintended consequence of just running a better business, those are still sustainability wins.
The polymer AM industry is expected to grow up to $34 billion by 2030, state 3D printing business media. And this year's exhibits prove exactly that. let's pan over to some product reviews that showcase the variety of this sector. Over at Hall 12.0, German manufacturer Trumpf has put their partially automated printing system on display that's made for industrial series production. Their product manager, Roland Spiegelhalter, explains what sets the TruePrint 5000 apart.
Yeah, this is our new TruePrint 5000. It's really the world premiere for this year. So we added to this machine our unique green laser technology, where we can really produce pure copper at a very high quality with perfect density and electrical conductivity.
And right across the hall is the TruePrint 1000 that has its world premiere. How would you say are these two printers different?
Yeah. So if you look at our portfolio, so the TruePrint 1000 is our smallest machine, specially designed for dental applications. And here we have really our workhorse. It's also a series production machine. We have 500-degree preheating in our cylinder concept that really helps a lot with serial production.
Educational and research institutions form an essential part of the exhibitor community at Formnext. Panning over to Innovations Campus, a joint technology platform between the University of Stuttgart and Karlsruhe Institute of Technology. Their project focuses on emission-free driving systems using additive manufacturing. Here's Thilo Zimmermann explaining how 3D printing fits into the bigger picture.
Well, what we're doing at the Innovation Campus Future Mobility is working on, for instance, electrical motors, where parts of an electrical motor can be 3D printed. So we have a car here, and in this car we then have different kind of electrical motors. We can test them, we can verify them.
AM is slowly revolutionizing the sports industry. A young Chicago-based startup improve upon an all-American racket sport. Ever heard of pickleball? James Hedrick from Azol 3D playfully tell us about it.
This is the first time you're going from a composite back to a single piece material, and also the first time you have a 3D printed part going into a hard impact sport. Pickleball is the fastest growing sport in the US. It's played on a tennis court, but slightly smaller. And what we're finding is that with 3D printing, you can completely change the sound of it. So if you give yours a whack,
Whack it is.
and you hear this one, how much quieter this is. This sport is incredibly annoying but amazingly fun to play. And by changing that sound, it can stay just as fun, but it changes the complete dynamics of the growth.
Following the sports theme, another exhibitor shows how 3D printing and fitness can indeed go hand in hand. Evonik supplies to the sporting goods industries and deal in high-performance polymers. You are seeing Yanfeng Liu, who demonstrates exercises on 3D printed equipment made out of photopolymers. The process here includes common UV curing. And again, Formnext has a lot in store for you. Make sure you do not miss these upcoming events. Ceramic AM hardware manufacturing is a leading service provider for AM technology. Projected to grow over $1.4 billion by 2030, the AM panel, supported by ceramic applications on the AM4U stage, shall discuss the sector in depth. Next, Juan Munguia shall delve into the future of 3D printing in space. Catch a glimpse at Hall 12.0, stand E38 at 11 a.m. Rounding it all up at Hall 11 Level O D72, watch Alex Kingsbury summarize key additive technology innovations at Formnext from 2:40 p.m. onwards. With these top stories adding wind to our sails, I wish you a successful fair day ahead in the Formnext arena. Don't forget to follow us on our social media platforms. You'll find the links below in the description area. Until then, stay tuned and keep thinking three-dimensional.
Printers come in all shapes and sizes. They can be small, they can be medium, but they can be massive. Have a look at that.
May the Formnext be with you. Yoda greets all its Formnext Star Wars fans. You may be nerds, but you're really cool. Ooh, what in the Charlie the Chocolate Factory? Formnext has so many flavors. Not just 3D printers, but apparently a 3D printed ice cream cone. Well, I'm off with my lovely strawberry ice cream. Hope it tastes as good as it looks. Look at the beauty I'm sitting on. What here is 3D printed, you might ask? Well, actually the brakes with the COCR alloy, and yes, the engines are, well, you guessed it, Harley Davidson. Well, get yourself a ride like this beauty today. 3D printers come in all shapes and sizes. They can be small, they can be medium, or they can be massive. This one right here is a tiny one, isn't it, Christian?
It's not a small printer, it's the only printer you can print parallel, so different projects and parts in one job.
How amazing is that? That's the only one in Formnext.
That's the only one in Formnext.
Incredible.
Exhibitions can be such an exhausting affair. Me and my sound man are knackered.
That's why we're sitting ourselves down on these comfy 3D printed furnitures. Max, comfy enough?
Awesome.
Formnext has the fix for your little craving. Grab yourself a donut today and enjoy what our 3D printing has to offer. We have cafes spread all around the fairgrounds.
I love Formnext.
Formnext is for us really a great pleasure.
This is my first time at Formnext actually, so it's almost overwhelming. I mean, just the magnitude of it. Everybody's here. I'm really excited
to network, to learn about the new development of technologies, and really be like a sponge to absorb new knowledge here today.
This is the place to be in our industry. Everyone who has something to say in additive manufacturing is here.
I like Formnext. This year is incredible. We are in a big booth together with Desktop Metal family. A lot of people, friends, partners, and we enjoy a lot.
And what you can see is that we have a very mature market at the moment. So those questions are on a much higher level than in the previous years. The contacts are of a very high quality, and this is really a lot of fun.
The crowds, the people, the energy, the enthusiasm, the exhibitors, the visitors, everything about it. This is a candy store for us young kids who love technology and getting our hands on parts. So it's you cannot be at a better place in Germany in November.
So who cannot love Formnext? That's the question.
Welcome to the fourth and last day of Formnext 2022 here in Frankfurt. I'm very happy that you zoomed in here in our morning talk today again, and I'm very happy to have you here, the audience at our booth, and you at home at the screens. I think we again will have a very impressive program today with a lot of lectures again here at the booth and a lot of discussions and conversations down. Sorry for that, but I'm coming to that topic a minute later. Maybe we start right now with that topic. No, I will first introduce my panel to you. As there is Tim Wischerop, he's head of division process chain automation of Fraunhofer IAPT. Good to have you here, Tim.
Thanks for having me.
Daniel Princh, he is the director consumer market solution EMEA of Stratasys. Good to have you here.
Thanks,
that you found the booth. I heard it was a bit struggle to get here.
I had to do Google Street Maps to get there.
Okay, perfect. Yeah. That's always a good helper. And again, Sven, you already know him. Everybody knows him. Co-host here and AM Insider. What I wanted to say, wow, that was a great party yesterday, wasn't it? So my voice is a little bit damaged, and it was a little bit late. Tim, did you attend the party? Look at him.
Yeah.
How good he's looking. I have a feeling that he maybe not have been there.
I have to admit that I skipped the party yesterday. Unfortunately, I heard it was a great event, but I've been here since Monday and been out every night, so yesterday I had to get a little bit of rest. But yeah, hope to be there next year again.
What a shame. It feels like, Sven, that we rocked the party. We both alone rocked the party yesterday. Because when I hear it right, Daniel, you've been attending neither yesterday.
So, guys, either give me a pill to become 20 years younger, and then I will attend all the parties, or my recipe to survive Formnext
is to go to bed. What should I say?
Is to go to bed early and be fresh early in the morning.
Perfect.
So skip the party, but we had a great opening at Stratasys booth. Probably you remember the stomp reinvented into recycling. That was good for the start.
But you know, my impression yesterday was that the whole community was there in Hall 9 and was dancing and rocking and doing conversation. And everybody, my feeling was everybody was so lucky, so glad to have each other. What was your impression, Sven?
I mean, yeah, that was the same impression I have. So the mood was excellent, and I think everybody was happy to celebrate again our reunion here at Formnext. And at the same day, I've never been there before, so now I understand why Friday normally it's the slowest day of the fair. It has nothing to do with visitors leaving. It's just about the party the day before.
Just all about the party. Yeah. People are getting late here, but we are on time. And maybe we can slip to a more professional topic. Yeah, in our, let's say, 20 minutes, we want to dive into some topics like hardware, maybe. Where are aspects of innovation that we can drive additive manufacturing forward? That is the question behind. And have we to use hardware? Have we to use new materials? Have we to use new machinery? Or the topic of automation is very, very important. Is it the process chain we have to look at? What is your impression? Where would you put your finger first?
I think it's probably a little bit of everything you mentioned. I mean, we need to increase every process step in the process chain, but I have the feeling that really addressing the process chain at all is the solution and the way we need to go. And this is also the discussions we had over the last days with the partners at our booth, etc. And when you walk around, you see that we understand that it's not only printing, but it's really the whole process. We need to automate the process, make post-processing more efficient, etc. And this is, I think, the big hurdle when we really want to go into industrial serial printing in the future.
So it's for you, it's a kind of red line through all the communities, through all the technologies that you want to automate all process steps, right?
I think it's exactly, automating all process steps and every step in between. I mean, at the moment, I think the machines itself, they are quite automated already. But, for example, building a part or build platform from like an LPBF machine to unpacking station, to surface treatment, there's still a lot of manual work necessary, which works for individual products, for small batch production. But if you want to go to large-scale industrial printing, that's not a solution, and you want to automate this process chain. And there's still a lack of solutions there and standards that are necessary. But I see that the topic is rising, and interest from the industry into that topic is rising and getting pressure on developing solutions for that.
You talked to a lot of guys on the fairground, and what was the result of these discussions?
I mean, yeah, in terms of result, up to now there is no real result. We had Stefan Ring from AM Flow here in our panel, who was where we were discussing the startup scenery and the culture and what needs to be invested in, and we strive the topic of automation. That there's a big need for it. So my question to you, Daniel, would be that you as a machine producer, are you pushing that topic as well? Because I mean, if we are not growing anymore because there's a missing part, or we stay in this prototyping phase and do not get to this industrial stage, so it would be bad for you as well. So are you pushing it, or supporting it, or doing automation by yourself?
I'll come to the answer, but I'd like to do one thing, right? I would like us to a little bit change the question, if I may, gentlemen, because if we're asking ourselves, what's the new hardware? What's the new automation? We are the amazing additive industry, and we're talking to ourselves. We're in the echo chamber. We're celebrating your achievements. What is fundamental question is, what is the problem that we're solving for the industry? The customer wants to do a sealed gasket for subwater. Customer wants to do a connector that survives, heat and chemical treatment. What is the use case? And then let's build the whole thing around it. So that's, I think, the fundamental question I would love to ask ourselves is, what is the use case that the big industry wants to solve? And then how do we actually solve it, the how? Now, to your question of the automation. On the hardware, there are obviously incremental improvements. And I can speak on behalf of polymers, because we are very much kind of polymers across all the product life cycle, so that's where we're watching. There's really nice incremental improvements. Edit laser here, higher resolution there, finer part quality over there, great stuff over there. I think to the question of automation, what is important is also to give customers a choice and recognize there are different versions of automations. There are people which want to have kind of all-in-one solution, press a green button, part comes out. There are people which want to have lights out, kind of line in, and there are people which say, just give me the Lego pieces, I want to do it myself and configure myself for that use case. And this is, to me, we're coming back to what is it that you are trying to solve? Are you trying to do interior parts for the plane? What is the best configuration of the automation? And that's the choice we need to give. There's not one answer. There's one important thing that I see in automation, is that there was the hardware box, there was this washing machine, we call it post-processing, doesn't talk to each other, but I think it's fundamental and it's already existing, and we need to evolve as an industry further, is to connect it to your point of all connectivity. So the machine knows, what is it that I'm post-processing? What's the recipe? What's the material? How do I take the treatment of that material and do it right? And I certify it. And I think actually we can get ahead of the conventional industry, because the injection molder just jets out parts and you have no clue what's happening. But we, because we are fully digital, we can know at every single part how the process looked like, and we can backtrace it. It's not just the aerospace question, it can be a problem for every industry.
So there are some sensors in injection molding too, so that's okay, but that's not the point. I slightly disagree what you said, because I'm not sure, on Tuesday or on Wednesday we had the VDMA here with a survey, and they were asking people what is the most problem that we do not go ahead with the growth of the market of additive manufacturing. And among others, the first point was cost. And so if people outside in the industry say, do we adopt a new technology where we are not so sure how it works, or where we have to get familiar with, and then somebody says, but no, don't do it right now because the costs are so high. Then we have a problem one step ahead of what you're saying. There might be a nice application that might look fancy or look useful to them, but if the financial guy says it's too much expensive, then you have you get not to the point that you can include the new application to your own business. And so I'm again there with I don't want to stress automation. I think we can talk a lot about a lot of other material, educational personnel who can handle everything in AM. I think we can talk about much aspects, but automation might be the point in getting the cost on a lower base, that the people will adopt it earlier. That was my idea behind the topic.
I think it's one key part of it exactly is the automation of that. I mean, when we take a look at where costs are being produced for an AM part, for like an application, and you go for serial production, we see that the biggest cost structure comes after the printing. I mean, we can increase the printer speed, add additional lasers to that, but this will not help to the solution of really bringing down the costs. It's really streamlining the everything that comes after the printing, where we see this is really the big hurdle. And it's about automation, it's one part of it, but it's also streamlining the process chain, maybe getting rid of one of the process steps. If I have a better printer, I maybe, for example, for metal part, I don't need to hip the part anymore. So I can completely get rid of one additional process step, which is also a significant cost driver.
Right.
So I think automation is one of the parts, but a very critical part to bring that down. Yeah.
At one point, I'm totally with you, by the way. As I'm originally from sales, sometimes what I'm missing is the customer perspective or the application perspective. Because we celebrate ourselves about new technology, new innovations, and everybody says, wow, this was incredible again. And then you ask, what is the application is used for? And then it's a niche thing, a tiny little thing that sounds crazy, but there won't be that many people using it, or there's no economic scale behind that. So there's where I'm totally with you. We should, in my opinion, in the industry, look a little bit more into where are applications that can be industrialized with AM, and there, of course, is then the need of automation, and this is the push then in doing streamlining, automation, saving costs, etc. That because then you need to do it, and then there's the scale behind it to do so. Do we have already such a, let's say, approach? We
definitely have use cases, right? But basically, I would answer to the cost question, and I'll come back to that, right? So, obviously, there's this very obvious answer that we are providing as an additive. Do you want to wait for your mold machine for 4 or 5 weeks and then ship it, etc., right? Versus doing it overnight. Obvious, right? All of us are telling that story, right? So that's a big kind of cost improvement. There's another thing to the cost, which is very important. Let's not forget, back to the echo chamber and who we are. And how significant are we outside to the world, right? We are 0.01% of the manufacturing. If you ask the Boston Consulting Group, when we are going to be, when we retire, 2020, 2040, we will be 1% of the total manufacturing. 1%, this is around 300 billion industry, right? That's a big one. We're like 10, 15, depending who you ask. 1% in 20 years. So this is the limitation of the scale. The moment we are scaling faster, and I would say depending on the technology, the total cost of ownership could be machine, but also as you go faster, it becomes a material. Because as the machines are becoming faster, the scale of the total cost of ownership of the machine gets smaller, and then is the material. And the material game is very, very simple. It's the volume game. The higher the volume, powders, photopolymers, thermoplastics, then the cost goes down. That's, to me, the key to unlock the lower cost, and it's kind of the chicken and egg. So we need to make the whole solution faster in order to have a higher consumption of materials, in order to put a pressure on the material vendors to make sure that we can lower the total cost per part and then drive further the adoption of additive to get to 1% in 18 years.
I get the point. Do you think we are sometimes, that's sometimes I ask myself, because I have a lot to do with industry as well, so are we too much in our own family, let's put it that way, and not considering the size?
Very often.
On the other side, and I must admit that, I mean, of course, we are small, but we should compare with the real impact. Is the impact only 0.01% in terms of questions of sustainability or questions of innovation or questions of solving problems of the world, or is that impact at least much higher? Because you can be pretty small but have a great impact. That would be a nice question. Tim, how do you see that?
I think there are special applications where additive manufacturing really contributes to a big impact. However, I definitely have to agree that the cost is always the point. I haven't seen anybody paying more for a part, even if it's better. I mean, for example, aerospace industry, they say you can pay like 1,000 euros per saving a kilogram. Nobody pays that. I haven't seen anybody paying that. So it's always critical to find the right application and then bringing that to the industry. And one point I wanted to add to your point is, from the customer perspective and automation point of view, if you have a special application, you can have already a very good, streamlined process exactly for that part. And you see that, I mean, also when you walk around the fair these days, for example, at our booth, the neighbor, and we have Dundee, and they have like scatter grids. I don't know how many thousand parts of that they print in serial production, tungsten. It's a very niche application, but it's a very, very nice niche application where you can see how you can streamline and optimize a specific part of a component and have a big impact on the overall performance of your machinery. And I think it's really looking for these small parts where additive manufacturing can add a good value, where the part is cheaper, and then increase the overall performance. And I've seen a couple of very good examples. I haven't seen before here on the booth these days, but it's small parts with big impact. Yeah.
And I would maybe add to that and answer to the previous question that you had, which is where we can add value beyond just the total revenue that we're bringing as an industry. For instance, with additive, you can create completely new products that were not possible to be done before. Think about, we're all aging, right? As European population, we need medical devices. We need medical devices, which, for instance, are dosing, drugs to us on a very customized
us to the point
level.
of individualization.
Exactly. So you can have a lot of individualization, not just for fun, not just that I want to have, name of my dashboard, but it's real practical implementation. So there's medical device industries, there's aerospace industries, there's other things where you can really have a customizable new product, and then we are creating more value than the conventional industry.
And then the size doesn't matter that much anymore. It's
exactly, because you don't have the reference, right? You have the reference. So if you have a drug delivery system, which is basically saving a patient, which you cannot have today, that's completely new added value that additive
That would
brings.
have been my next question to you. How do you drive at Stratasys the advantage of individualization of the products in marketing, in awareness for the end users, for the customers? Because if you can do that, if you can get it in your head that you do not need to ship thousands of shoes, but just the one which is good fitting, then that it's the point of sustainability. Well, before we started our talk here, we had to chat about sustainability, and that is a sustainability point of view, and that may be crucial to get into the mass production, but not mass production as it's done with injection molding, but mass production because everybody gets his individualized product. Right. And I'm talking about the industry as well, like spare parts and something like this, which might be, you cannot install the original spare part because the machine has, some lifetime, and you cannot put in a completely new part. You have to put in an adjusted part. That may be a real crucial point to get fast forward in additive.
So let me build on that question. I don't think that company A, B, C here is going to create a new industry. This is not for us to do the job. I think when we are going to see the proliferation of additive is where the Adidas and Nikes and Fords and GMs and Airbuses are basically naturally having the capillarity of adopting additive. This is very important that in few years in the past, everyone in this industry said, I have my use case, I'm company A, and I'm company B, I have my own use case. It's all locked, I keep it for myself. This fragmentation of the business will bring us nowhere. If you look at other industries, competitors are partners, they work with each other, they compete each other. We need to do much more partnership with the industry leaders. So what we are doing, to your question at Stratasys, we're really going verticals, aerospace, automotive, general manufacturing, consumer goods, dental, medical devices. And each, we are basically working with few key leading names, which are, they want to adopt additive, we're relevant for them, they're relevant for us, and we build the use cases in those industries with those companies, not ourselves, with those companies. So you will see already, Airbus and all the other guys are bringing the standardized additive use cases out to the market, to their supply chains. Now, what's needed? What's needed? No more hype, please. No more hype. We need data, testing, validation, processes, application guides, boring, hard work to get into the manufacturing. That's the way.
That's why I was so excited when we had our partner country France here on stage, because I first thought, okay, we present a partner country, it's okay. But then we had Decathlon, we had Renault, and they had their use cases with them. Like Decathlon, they couldn't deliver 6,000 bikes, so they needed to use additive in order to print a plastic part and to get the cable through the bike. And it worked out. The part was even better than the original one they planned. It was quite expensive, yeah, but they delivered on time. And those are the stories where you see the advantages of additive as you said, in a company that everybody knows, and this creates awareness, basically. Yeah.
When you're talking about the verticals, can you give us a number? How many products do you sell to a single customer? So in average.
So basically, today there are the people which have adopted additive, right? Especially the aerospace business and the leading automotive brands, because for aerospace, the lightweighting, that was immediate thing that they recognized 20, 25 years ago. We already have, I would say, farms. There are already farms of machines which are basically producing. But you're right, it's this 0 point something of the total BOM. It's this really, really small part. It's basically serving, you know, what the example that you just gave, there's kind of two ways to think about it. Additive is saving cost, or additive is creating new revenue. Additive is saving costs is like, okay, spare part problems, supply chain issues, okay, I plug in additive as a plaster, and it saves my cost and saves my production line. But I think what we'll see more where additive will bring value is when people think about additive as a new revenue stream. What else can I do with this rather than just, you know, plastering the problem? And I think that's where I think additive can add way more value. Many customers have started with this, can this plaster my problem? Right? Can I do spare parts?
Yeah, true.
And now they are moving into, hey, I can actually do much more high-value products and differentiate myself from the competition in my vertical by having additively or digitally designed workflow, which ends up with an additively made product.
And with that, the amount of sold or produced parts is increasing. I get
Absolutely.
it right. And
Absolutely.
you don't want to tell us the one or the other number.
I know the numbers by heart. I cannot go into the details, but it's really, you know, per customer, it's tens of systems which are running today production already. This is already happening. Or very often, what happens is that the big OEM is standardizing the process and goes to the suppliers, which have service bureaus, service offices providing the parts according to the recipe. Basically, the most advanced industry is aerospace. They run in this modus operandi for the past 7-8 years.
Which is, you tell us about a very good customer journey, let's say. We have a journey today, the last day of the exhibition. With a quick answer, please. What will you look at the last hours of exhibition, and what is your tip to our spectators out there?
Very good question, because I didn't have too much time to walk around and really see the booth. So this is what I will do
so
today.
It's mandatory to get an overview.
And Friday is a good day, as you mentioned. It's usually the calmest day, so you actually have time to talk to the guys on the booth. So this is what I will focus on today.
Thank you, Tim. What will you do today?
We have some surprising executive visits from people that are, you know, in this big industry. So I'll take care of them. And in the afternoon, I'll go drink beer with my competitors.
Perfect. Sven, I don't have to ask you because
I
we
do
are
pretty
here
much
on
the same
stage.
as you do.
the same as I do. So, dear spectators out there, the audience, we will be here for you the whole day. But now let's start into the trade show day together. After some short Formnext highlights, we will have an AM panel here supported by ceramic applications. And Sven, you asked me about where are the ceramic applications. They will be here on stage right after our Formnext highlights. See you then.
Pandemonium rages in Hall 12.0 here at Formnext as visitors from all across storm to find out what the latest in technology in 3D printing and additive manufacturing is. But what interests us is what the visitors think this year are the technological highlights. Let's find out.
So the jetting technologies, working with metals and ceramic powders, this is something that I also looking for our application for machine parts.
With technical exchange, we spoke to multiple end users, figuring out how additive manufacturing can help them in the application development, understanding the selection of parts, selection of technology that is suitable for application. The methodologies that we see today are, way more than what it used to be back in the days.
Software developments in metal 3D printing, optimizing build speeds, that sort of thing.
This is the on the software side. Slicers, simulation softwares, that's something that I would like to still check.
Peak 3D printing and the actual build volumes.
The metal techniques, the metal technology. We are a service bureau and we're producing, spare parts, mainly metallic. So we're looking at the powder bed fusion techniques.
What's interesting for us is something called cold fusion. So the polymer-bound metal powder parts that can be run on polymer systems. It's interesting.
3D, free-form object printing. I believe that these technologies enabled by the software will scale down in price and cost and will be available for more industries than today.
Everything. It's prototyping, it's production. There's no industry, there's no need for 3D printing. Everyone can use a 3D printer.
We're here at Evonik, where we've got sports equipment all around us. And how does it really marry together with 3D printing? Mr. Lou over here is going to show us. Well, that's the power we're talking about. This board on which Mr. Lou's showing amazing balance is made with the nylon 12 polymer. Evonik's amazing technology and Mr. Lou's proper balance. I must say I'm impressed.
Thank you.
1021, 1022, 1023. Oh my God. Oh, Mr. Lou, that was a good workout.
Thank you.
Keep the innovation happening.
Sure, absolutely.
And keep making sports better.
Yeah, absolutely.
I should hit the gym someday. Do some more cardio? Okay. Well, Mr. Lou, thank you. You're a sport. Thank you. Oh my God, that grip. He works out. He works out. I see the abs coming. Bye.
Thank you.
Hello, ladies and gentlemen, and welcome back here at the AM4CU stage at our last and unfortunately final day at Formnext 2021. After our interesting morning talk, we will kick off the day with a very interesting panel covering the topic of ceramics in additive manufacturing. The panel will discuss current status, the potential in regards of applications for the industry, and of course, future trends. We have an excellent lineup, so let me quickly introduce you our panelists. So first of all, we have Dr. Steffen Walter, Head of Processes and Product Development from Alumina Systems GmbH. Then we have Richard Guignon over there, who's CEO of 3D Sinto. Then we have Dr. Tassilo Moritz, Head of Department of Processes and Components at Fraunhofer Institute for Ceramic Technology and Systems. A very long title, but I hope I put it correctly. Then we had Dr. Holger Friedrich, Group Leader Ceramics at Fraunhofer. Perfect, good to have you here. Then we have Iris Heibel, Sales Manager, grow platform from Bosch Advanced Ceramics. And last but not least, we have Johannes Homer. There's nothing more, Johannes, and I think you need to introduce later on yourself. Thank you so much. And last but not least, our moderator for the session today is Ms. Karen Scharrer, Editor-in-Chief from the Göller Verlag. Karen, I will head over to you.
Thanks
Enjoy
a lot.
the session.
So possibly we get our backup presentation. Excellent. So I'm representing Ceramic Applications. That's one of our magazines, but Ceramic Applications is not only a magazine which is published in print and online, it's also a networking platform where about 80 companies are together, 35 from Germany, the most others from Europe, but we have also members from India, Japan, and the United States. All have expertise in technical ceramics. And in the last years, in the ceramic industry, additive manufacturing became more and more important. And now my friends here that are, let's say, from our group of 80 companies, maybe the most important expert in this field. But I want to give a brief introduction to you, technical ceramics, because ceramics sometimes is received as, oh, ceramics is my cup in the morning or my tiles or my bathroom. As most technical ceramic components are in some way hidden champions, that are components which are an element of a very complex system, and I put here together all the potential user industries, and not only potential, also really user industries. That's from automotive, aviation, space travel, energy technology, where, and corrosion prediction is important, medical technology, electronics, environment, heat treatment. So I don't want to read all details, and especially now where climate change is an issue, all this insulation, or for water technology, environmental technology, ceramics can offer a lot. It's more a general survey. Ceramics is a powder technology. We use either oxide, silicate-based, or nitride or carbide-based materials, even reinforced materials in part of the material portfolio. I put in final products are mainly very dense products. Densification has to be done by heat treatment, so we have firing processes dependent on the material, let's say from 1300 degree to 1800 degree. That's why ceramic products are compared to polymer or metal-based products pretty often the most expensive ones, but on the other hand, there's a need for a technical solution when you have to reach either high heat resistance or electrical or thermal insulation, extreme corrosion resistance. So when, let's say, harsh working environment is the case, you may need ceramic components. And of course, without additive manufacturing for decades, ceramics has been manufactured either in shaping technologies like casting, like pressing, extrusion. And in the last, let's say, 15 years, initially it was mainly research, pretty much additive manufacturing systems were developed, and I hand over now to Tassilo Moritz, who supported me to give a short overview and prepared this little chart, and I think it's for you now to explain a little bit which type of additive manufacturing systems ceramists prefer to use.
Yes, in the field of additive manufacturing of ceramics, we have a huge bundle of different technologies which we might use. And the processes I mentioned here are not complete, especially direct ink writing, for instance, is missing. But we can divide roughly additive manufacturing of ceramics either in direct and indirect methods, but more practical from our point of view is to divide into powder-based methods and suspension or feedstock-based methods, because this describes how the product will be after the process, either porous or dense. But ceramic additive manufacturing remains powder technology. And this is one thing I have really to emphasize, because when your process is ready, you will not get a ceramic part from the building platform. You will attain a green part in all these additive manufacturing methods. And now you have to debind this part and you have to sinter the part. After the shaping process, it has a green, or it has green dimensions, and now during the heat treatment, it will shrink. And so you have to take into consideration this shrinkage already during your building process, and you have to work with an oversizing factor. This is very important for additive manufacturing of ceramics.
Okay, we promised to show some components. I said ceramic is mostly, price-wise, the most luxury solution, and that's why I asked my partners to present nice applications. And to be impressive, we thought first we start with a space. And I hand over to Richard from 3D Ceram Cinto. They are equipment manufacturers, printing, and of course they have the responsibility for the process chain as well. And I kindly ask you to give us some details on this application you developed with your partner.
Thank you, Karin. So in the whole application you mentioned, there is one which is quite important. That's the space application. You know, ceramic is already used in the space, in a conventional space, I would say. But 3D printing is quite interesting for different reasons. Why 3D printing in space? Because if you save 1 kilo of components, you save roughly 200,000 euros. So you can understand that there is a big interest to have design, lightweight design. The second interest, I will take the example of the antenna, which is on the left or right, but the one that you start with a sketch and you end up with a final product. They use ceramic for the dielectric properties, very unique. It's a zirconia, and ceramic in the space can stand a very complicated and hard condition. You know, you have ionization during the launch. It's very hard because you have vibration, and you have a heat and a cold and a cycle and so on. So there are not so many materials that can stand in the space. Ceramic can. And on this example, we add some properties, electromagnetic properties, dielectric, and they are able, with the shape which is described on the sketch, to modulate the dielectric properties according to the need of the customers. Okay, that's the good point. So flexibility of the 3D and the properties of the ceramic that they combine. And another point which is quite important, why it's very, I would not say common, but why now we can find more and more ceramic in the space and more 3D printing in the space, it's because 3D printing is a flexible, low, short development time. Between the prototype and the part sent in the space, it was 18 months. From the concept to the final parts, 18 months. You cannot do that with traditional technology. On the other side, it's another example which is thruster. What is a thruster? The new space, you have mini satellite at 400 kilometers. If you launch satellite at 400 kilometers, very soon they will collapse in the atmosphere. So you need engines. We call it thruster. And most of the shape of this thruster are made with another ceramic. And this time we are not looking for the dielectric properties, but the thermal properties, insulation, they should stand heat in order that the mini satellite could be moved to another place, or simply they will not collapse into the atmosphere. So space, you see, it's an early adopter for 3D printing ceramic for different applications. I could speak about mirrors, and other stuff that we, 3D Ceram has developed with customers.
Thank you so much, Lisa. And brings us to back up, give an example. It's a project from Fraunhofer, and Tassilo, I think you will give a short explanation to this aerospike.
Yes, we have an application pointing into the same direction, as you mentioned, Richard. We developed, together with the Technical University of Dresden, an aerospike engine for a very low thrust class. Because for stabilizing a mini satellite in the orbit, or to let him return to Earth, we only need some Newton of power. And the challenge for making such components is to have very tight tolerances. And this is a very small engine which we made here by wet photopolymerization, basing on alumina. And the surface and the tolerances were really good and convincing for such an application here.
Okay, thank you. Now I hand over to Johannes. We are already in a state where we can do multi-material printing, and that's why I asked Johannes to give us an example. And you see, it's copper and ceramics, and more details you will learn from Johannes.
Yeah, thank you very much. So what we see here is a multi-material component. So basically, as we already heard, one of the advantages of ceramics is that it's non-conductive. So you need sometimes an isolating effect. And here what we see is that copper, as a conductive material, can be used, but you need an isolator. And we are combining here ceramics and metals in 3D printing. This is already well known from LTTC, so low temperature co-fired ceramics. But what we can do now is really to bring this into 3D printing. We have systems developed to make that happen, and there are basically a lot of applications for that. Especially, of course, anywhere where you need conductive materials. But of course, you can also combine ceramics with ceramics, but also ceramics with metals. And yeah, I think from this type of thing, this is really the next step of additive manufacturing, of combining two materials. And you can also do functionally graded materials. There are a lot of potential with this multi-material in that sense. Thank you.
Thank you. Okay, we go back to Richard. He gave us an example. It's good to have it, but I think nobody wants to be the one who needs it, but give us some background on the activities in biomedical, because your company had, in very early days, started with this field.
Yeah, just before I was talking about space application, which is quite new, but keep in mind that 3D printing ceramic is not a new thing. You know, we already printing implants, skull implant in 2005, or bone substitutes for spinal cages since 2007. So why do we use ceramic in this case? 3D printing is, I would say, just there to bring several functions to the product. This, you all know about that. So if I take the example of the skull implant, you have a customized implant. Great. So 3D printing is really a good answer. But you can have on the outside porosity to allow the bone to grow into it, to fix the implant. And you can decide to have some bigger holes to fix the implant, to let the copper to acquire the implant and to fix it. But the real thing behind why it's very popular and developing more and more could be skull implant or cages and so on, or it could be also dental application, or it could be other implants. It's because it saves time to the surgeon. That's really the point. So it means in the same period of time you can do more case than before. So you can make a little bit more money, because at the end of the game, if you print, it's sooner or later someone has to make a little bit more money than before. Otherwise, there is no future for the 3D printing.
Thank you. Okay, now I have from Iris a very nice selection of parts. So 3D printed ceramics parts can be up to 1 meter or larger, but that's the opposite side. They can be very small, and it's your turn, Iris, to give some explanation to this. It looks a little bit like jewelry, but it's a very technical product.
Thank you for your introduction. So, as Bosch Advanced Ceramics, we are producing with stereolithography oxide ceramics, very complex shapes. These are some explanations, some parts which we produce to show how complex we could produce the ceramics. Very tiny details, also very tiny channels into the ceramic, which is not possible to do with traditional ceramic production processes. And we are focusing on dense materials. So these parts are having the best properties out of this process. And we are focusing on various markets like electronics, like medical application for medical devices. The trend in the technical ceramic is going to tinier parts, especially for the medical application, where you need high precision also, and a nice surface, good isolation behavior of the ceramics, but also a hard material which could be used in as a scissor, for example. And so these are some ideas which we would like to show to you, to give you some possibilities to maybe change your design for your products, which is important, especially if we look to engineering partners. So you can do much more than you have been able to do until now. So this is what I would like to present to you.
Okay, thanks a lot. Okay, so it's for Holger.
Thank you very much. Yes, well, you can see two different kinds of materials here, which I have chosen. The white material, these are sensor heads that we use for and produce in our lab for investigating thermal processes in furnaces. And the big advantage of 3D printing here is that we have a high flexibility on which functionalities we include in these sensor heads. And they are very delicate, they are very robust, they are made from alumina, and have a very good surface quality, and alumina is very corrosive resistant, so it's ideal for investigating furnaces and to optimize them with respect to energy efficiency and so on. And you can see in the top picture on the right a further principle of 3D printing of ceramics from my point of view. It's the combination of different materials. So you can see here the sensor head made from alumina, and then on the right side you can see a tube which is made from a ceramic matrix composite, which is very thermal shock resistant, and those are combined by a glass ceramic. So you take the best out of all for building up the whole component. So there are a lot of advantages using and doing this in 3D printing. And on the left side you can see some kind of tower. So this has been produced completely differently. It's a binder jetting process. And whereas we have the sintering process for the alumina, for the binder jetting process, we don't have to sinter. This is a silicon-infiltrated silicon carbide material. It's baskets which we use for producing our ceramic fibers that we produce in-house for heat treatment. And you can see the very open structure. It's again very lightweight, and it's rather large components. And it's a completely different material, and by the silicon carbide product, you can actually have a complete near-net shape process. You print a powder bed material, a green material, which has the final dimension, and that is infiltrated by a molten metal, in this case silicon, which fills out all the pores and gives a very stable material. And again, it's very flexible. You can produce larger parts. And here's another principle which I wanted to show. You can see that the baskets are made up of several components. So we could have printed one of these baskets in a single print, but then it would have been only one basket per print. By taking it into several parts, we could print up to 12, which increases efficiency a lot, and we can work much more efficiently here. So it's different principles which you have to consider when using 3D printing for ceramics. One point is also the thermal processes, which have already been mentioned a lot. It's very important to understand the processes of debinding, sintering, to actually have the final product in the first process run, and that you don't need 10 trials to get the final dimensions. And that's why everyone is putting a lot of effort into these optimization processes. Thank you.
Thank you, Holger. Yeah, we have now here a nice example Stefan will present, and not only you see the picture, we have one of the smaller rings here to show it from stage, and when we finish you can come and look more closely. And I think you got already some keywords, precision of the process. Ceramic production is a very long process chain, and reliability, precision are very challenging, but you know it better. It's your daily job.
Okay, thank you. So one other important part in the industry right now is to have a look on in the semiconductor field. So semiconductor industry is increasing a lot, and as you know, the time between chip generation from one to one is decreasing, so it's getting shorter. So the development time is decreasing. And we were able to develop in the last 2.5 years a new technology with this sort of rings here. So this ring is used for atomic layer deposition. I brought here an exponent with me. So this is the size of a ring with 380 in diameter. So this is the smaller one of this you can see here. And the other is, the bigger size you see is around 500. So 500 in diameter, all made out of ceramic and 3D printed in our big machine. So just to give you a brief overview what such a ring is doing. So imagine that such a ring, they have here inside, they have certain nozzles, they have a certain design, which is very important for for the precipitation of the reactants. And what this ring is clicked into a plate where also the connections of the gases are inside. And in between the ring and the wafer, which is located underneath, there is a plasma in between. So during the precipitation process, you have you spray in certain gases, and you precipitate the reactants onto the wafer. And what you do right now is you can do with this technology, is that you're able to do the precipitation process and the etching process in one step. So this is completely new, and this also shortens the time for a new generation of semiconductor process and ICs.
Thank you. Yeah, it's again from Tassilo, an example. So I hand over for the thick film heaters to you again.
Yes, for many applications, it might not be interesting to have an active heating, but also an active cooling, because an active cooling can save a lot of time during different processes. And in our special field here, we produced, during the pandemic, a PCR module. And this is a biochemical reactor for testing, and it needs an active heating for initiating a biological reaction, and it needs an active cooling for interrupting this biological reaction at a certain time. And the wet photopolymerization allows us for making inner hollow channels in a ceramic part. On the left-hand side, you can see this inner channel structure, and then we printed by screen printing a conductive layer onto the part for attaining an active heating. And so we could combine active cooling with active heating for this biological or biochemical reaction which we want to influence here.
Thanks a lot. Okay, that was, let's say, part one. I asked my colleagues here to present some interesting examples to show you that ceramics is not only the coffee cup in the morning, that ceramics can be really a solution provider. And so as a key work, I used your ceram factoring. And we have here 3 columns. I want to discuss in the second part. AM in the research will never stop from various aspects. But meanwhile, and we are very proud that we have additive manufacturing developed as an additional shaping technology to manufacture ceramic components. And what's also a good news, that AM helps to get newcomers in our community, because as a ceramist, and as I'm a ceramic engineer, that's why I'm allowed to say it, we are somehow a little bit a close group sometimes. We know each other a long time, and but we want to have fresh ideas, and that's why when I follow the market of the last 10 years, a very good news is that we can attract people who are used to other materials, and there will not be a long discussion, but we have an example provided by Richard, and maybe you give some comments on this really new equipment and the idea behind, because it's not the thought to have it for series production, it's maybe for education and for new partners.
Yeah, like Tassimo presented, there are several processes in 3D printing, as you know, almost the same as for metal or polymer or plastic. And well, the most effective right now, I mean, to get a real dense and good product is SLA, stereolithography, with laser or DLP, whatever. There are some pros and cons on both sides. But actually, we should give the freedom to research people or to newcomers to choose the technology they want to develop or to understand which one is the best. So we have developed at 3D Ceram a new machine whose name is multi-additive technology, which means that we have a frame. You know, it's a small machine which can print on 20, 20, and 20 centimeter. And we can adapt several heads on it. It could be a filament printer, it could be a robocasting printer. We can also have a CNC head on top of it. And just to say, well, try, develop, and see how to develop the application as well. Because we have so many times people coming and asking, okay, what can I do with? And I mean, as an equipment supplier or process supplier, it's not my duty to say, okay, the market is there, but here are the tools for you to develop the market. And the example of PCR is quite good, PCR, because there was one technology and they found the market. Now, with this tool, it's a flexible tool to adapt the right technology, the right material to the right market. So that's what we want to do, and to go with our customers in order to develop the 3D printing in ceramic.
Thank you. I go back now because more important are the other two columns. Maybe I am in research. I kindly asked Tassilo to come in again for a certain reason. Of course, he is here as representative of Fraunhofer, but for many years you were very, very active in the German Ceramic Society, taking care of the expert group Additive Manufacturing. It was called initially seen Additive Manufacturing, where a lot of institutes work together, so I have a good overview what was going on in research. And the research will never stop, because on the one hand, you showed the most important techniques. There are others still in process to be developed, to be adapted. We had already an example for hybrid solutions in components, and we are pretty sure we will have new materials in future. And so I kindly give some insight to the last 10 years, because this expert group is now renamed to User Group of Additive Manufacturing, which leads us to ceramic production later on. Thank you.
Yes. Yes. This additive manufacturing group, which is called User Group Additive Ceramic Manufacturing in the German Ceramic Society, does not only bundle the competences of research institutes. We also have 11 industrial partners. All of them are users of additive manufacturing technologies. And we want to bring all these technologies onto a productive level. Yeah? And we know that we have a lot to do in this field, especially in research and in pushing these technologies onto a productive level. At first, we have to find a way to attain properties which are comparable with conventionally shaped components. We have to increase the productivity. We have to be sure that the properties of an additively manufactured parts are the same in comparison to a conventionally shaped part. And furthermore, we want to combine such additive manufacturing technologies with conventional technologies. We want to combine different materials. For getting to more productive solution, we also will have to implement non-destructive testing as inline measuring methods into the processes for being able in future to build really intelligent machines which learn when something goes wrong in the process, which can stop the process and which may actively repair a part or which can adjust their process parameters to getting again into a productive process.
Thank you.
All these are the tasks we will try to solve within such a user group.
Thank you. Yeah, but now I want to go to the column in the middle. I am in production, and I hand over to Johannes again. It was for sure a long way to go from research. Next was prototyping technology, but we are now really proud that we can say it's a production technology. In fact, at the moment nearby, near Düsseldorf, a production plant is erected to be opened in January. So it's reality, and I got this nice slide from Johannes, who will expand a little bit on this project with your partner Steinbach from Germany. And I think we have some nice figures here, because when it's production, it's reliability, reproducibility, and get us a little bit your experience.
Yeah, thank you very much. You are completely right. I think there is, of course, there's the need of doing also small series and prototyping, but the big challenge is then to go into serial production. And I think here we've come a long way, and it was a tough way, but we are now really in serial production of additive manufacturing of ceramics, and there, you know, we have a little bit tougher requirements. And here with our partner Steinbach, or not we, but actually they producing already in serial some medical parts. These are some tubes. So these are 12,000 parts per year, which is needed. They're produced actually in a couple of weeks to do them, and the requirements are really tough. So about plus 20 microns on the outer geometry, what has to be achieved. And this part can only be produced by additive manufacturing, because I don't know if you can see it, but it makes a small bend. This little tube, and this is the big aim here. And we have here wall thickness as well of very, very small, so 0.2 millimeters is the wall thickness here. And if you're talking about 12,000 parts per year, it's also not, or more or less not possible to post-machine them or to finish them. So they have to be as printed, and here we're achieving a very good surface roughness, so an RA value of well below 1 micron, so 0.4 micrometer. And I think here you see an example that additive manufacturing is not just about prototyping, but also already as a serial production technology.
Thank you. Yeah, I only do not want only to show results, as we have experts who work on the technology chain. Maybe we go back to Steffen with this ring you have seen. On the one hand, you have to ensure high precision and being in a status which is ceramic production. It's no more a first prototype. You have to calculate your production costs, and I know that you have different concepts to produce this ring. In theory, it's possible to print it because you have a large machine, but you told me yesterday there are other aspects to think about process and efficiency of process in-house. Possibly you give some insights on this as well.
Yes, I can. So when you think about to produce such a ring in this size, which is really one of the biggest actually in the world, what we have, then you have to think about a sort of strategy you need and a process chain to really get out high quality at the end to finalize a ring like this. So at the beginning, sure, there's the thinking, well, you can print this ring in one piece. This is possible. But then you have to think about, well, how do I get a ring, such a ring in that size from the platform, and then think about the debinding process, which is a second step, and then the final step is the sintering step. And each time you're sweating, is the ring coming out properly after that process step? And so that we decided to work or to produce such a ring in a form of modular concept. So what that means that we divided the rings in several pieces, and we print these parts on the machine. And so you gain two other aspects. So the first aspect is that you have you do not only print one ring on the platform. With this modular concept, you can print 4, 5, or 6 ring in one print, so you increase the production. And the second is, afterwards, you have to think about, well, is this ring size the only ring size you will have? Right now, we are talking about 380 micrometers or 500. But what happens if our client is coming and says, okay, right now I need a ring of 700 or 1 meter? So then you are able to do this because with this sort of modular concept, you are able to produce that sizes. So and if you have such parts, these will be glazed afterwards, so to the complete ring. And the insert or how it is done, this is really know-how of our company.
Yeah, and I also know that a special know-how of your company is joining technologies. Yeah. That's was a good aspect to find this more efficient, cost-wise, more efficient solution, and also when it comes to reliability. Yeah, I have additive manufacturing and injection molding. That's another nice story. In ceramic technology, we have, I think, for more than 20 years injection molding, and I'm more an observer of the community. My impression is that with these advances in additive manufacturing, even this injection molding technology got a push, yeah, because they got competition, yeah, and I think it's again you who had projects where it was started with additive manufacturing, and for some reasons later transferred to injection molding. Maybe one want to give a comment on this.
Yes, additive manufacturing helps us a lot in ceramic injection molding, because we now have the opportunity to do a so-called free-form injection molding technique. We can build tool inserts by additive manufacturing. We can make polymeric tool inserts, and now we are able to make injection molding of only single parts. This would never be possible so far because we always had to build an expensive tool for injection molding, and the tool cannot be changed so easy. And such a tool is for several tens of thousands of pieces. But with such polymeric, additively manufactured inserts, we can now make only one part. And so we can also make prototypes by injection molding. And there's another point. We can make series parts by ceramic injection molding. And then we can individualize such components by combining ceramic injection molding with additive manufacturing.
Yeah, so it's again an example that additive manufacturing helped a lot to inspire ceramists to conquer new fields. And that's always good news for me. I have one point. Additive manufacturing can even be used in ceramic production for preforms. I refer a little bit to your LIS project. It's maybe very specific, but maybe you can give one or two comments on this.
Yeah, I think as Tasla already pointed out at the very beginning, there are different types of technologies available, and I think there is no superior technology which says, okay, this can solve all issues with all additive manufacturing things. So basically there are, for each application, for each requirement, you have a special purpose. So as you have drilling and machining and turning, that's the same in additive manufacturing. You have different technologies, and we have also one technology where you can make preforms, and which is more near net shape, but has other advantages compared to the current available technologies.
Yeah, so I think we have maybe the last 5 minutes, and I put in the keyword visions. Yeah, so at the moment we are really in this interesting phase to confirm that's in series production. And maybe I come back to Richard again, because as an equipment supplier, and the same applies for you, Johannes, of course you are equipment machine suppliers, but you are partners for those who want to enter either the ceramic scene, or what's more often when it's ceramic productions, they want to have this additional shaping technology, and your advice starts to help them to prepare paste or whatever they need, to give some advices for the post-processing. So what's from your point of view, Richard, the situation, and what do you expect in the next 2-3 years for the development for series production, because you have some additional steps already at hand? Yeah.
Well, from an equipment supplier or process provider point of view, but would be good to ask for a part supplier, because normally we follow what the market is asking. We do see that we need automatization of the process. To print automatically, we do it for years, or our customers are doing it for years, even serial production with big surface and so on. But what is important is to be able to produce, to manufacture automatically parts, having nobody to remove the parts, having nobody to clean the parts from slurry, powder, or whatsoever, having nobody to put the parts into the kiln. Because if you look at the ceramic industry, it's highly automated in order to cut down the price. So if you look at 3D printing, and if you look at for years ago, you have to take the parts, you have to clean the parts, you have to put them in the kiln, to remove the kiln. No way for that. So I think we really have to think in order to go into the direction of automatization. And it depends on the technology which is suitable for the application. Regarding slurries, you know, slurries are raw material, I would say, because it's really depending on the technology that we are addressing. The raw material is depending on the application. So we see different, it's really depending from countries to countries. You don't have the same needs in the US or in Asia or in Europe, because it depends where the market is very strong. So let's see. So I think it would be good to ask a technical ceramic supplier to ask his point of view. And I mean, as a process provider, we will follow them. So that will be my point.
So you asked me for Steffen and his vision maybe shortly. Yeah? I think in Illumina Systems, what I observed the last years, it's a very creative company, and I always have a surprise when I have a visit and get some more.
We as well. No. So, talking from production side means that, well, the additive manufacturing means for us that we have to, in the future and visions, we have to combine techniques with additive manufacturing. So that means, for example, right now we follow the bonding. So we have the glazing process, and we have also later on you have to bring some metal parts onto it. So that means that you have metallization and galvanic processes and stuff like that. And maybe future things could be that also electric circuits can be implemented into such parts to solve problems of electrical charging, for example.
Okay, thank you. I want to finalize or to close the session. Don't hesitate to visit these experts in Hall 11, first level, because even if you are not a specialist in ceramics, you get backup when in our group of ceramic application, when you need to know something about powder, when you need to know something about additive manufacturing technology. People like Holger have worked a lot on the post processes, what's thermal technology to get it optimized. Because mainly the challenge was to get the same high density of the products, because a lot of properties depend on density of our materials. So I hope we gave you an insight that ceramics, it's not only the tile. We had from space to biomedical to semiconductor industry a lot. And as a very last slide, I hope I have something very different. It was done at Fraunhofer in Dresden, and they worked with famous museums of Dresden. And the last sentence is for Tassilo to explain what an elephant made from porcelain has to do with additive manufacturing.
In this historical vase, the trunk of this elephant got lost 200 years ago, and there was no mold for replacing this trunk. And we were asked to do this by additive manufacturing, and we used again that photopolymerization. We made a porcelain slurry made of Meissen porcelain and produced this trunk by the original part, which can be seen here on the right-hand side. And it could be really replaced by the Staatliche Porzellansammlung Dresden. And now it can be seen there in the museum.
Yeah. So ceramics from the museum to space, that was maybe in a nutshell what we wanted to discuss. And thank you for listening to us, and we hope to see you a little bit later. Thanks a lot.
Excellent. Thank you so much, Karen and her guests. Very excellent insight into ceramics. This shows again what kind of variety of topics we strive here at our Aim for You stage. It was a pleasure to have you here. Thank you for the interest in discussion. We will head over to some more expert insights on applications from the industry. But before we do that, we get another highlight block for you. So stay tuned. We see you in a couple of minutes.
So Mobility Goes Additive has its premises in Berlin, which is the capital of additive manufacturing, and therefore we need a lot of contacts. Here we can meet all of our members, and we also meet a lot of users, which might not have booths, but we have them in talks, and the quality level is very high.
Boeing is always looking to onboard the latest technologies. Anything that adds value to Boeing business cases, to Boeing products, right? So we want to see what the latest developments are and really to stay on top of that. And Formnext, I think, is fair to say, has it all.
For us, Formnext is so important to be here because we have outreach to the whole world. We are a scale-up and we see so many decision makers over here. There's no other place than this to challenge the vision and make it work.
Yeah, so of course Formnext, I mean, that's the big event for us in the year. So everything that we do when it comes to product launches is always around, we always plan it to launch at Formnext. So of course this is very important for us.
Formnext is so important to AM Ventures because everyone is here. This is where the decision makers from all over the world are gathering 1 week per year in Frankfurt. This is where you have to be if you want to do something, if you want to build a business in our industry. This is where you have to be.
All aboard, I'm sitting inside the Uila here at Formnext, and I'm pedaling, but I'm getting nowhere. However, the pedaling is chainless. That's what drives this technology. The pedaling turns the engine and then turns the motor. And the lightweight material is a polymer named ASA. So, I'm off to get a nice pint. See you inside the Uila soon. It's really comfy. We're here at 3D Step at Formnext. Welcome, Pekka. Tell us about the services that you're providing and the product that we see in front of us.
All right, we are 3D Step, a metal and plastic 3D service provider from Finland. And what we do is contract manufacturing, serial manufacturing for industries.
And what is it that we see in front of us? Tell us about the products that we see in front of us here.
This is an example of serial production. This our customer is Mirka in Finland, and this is a component for robotic grinder. This has 120 components that are printed in one go, and here's the one specific component that this has. And this is an example of what we do as a daily business.
Welcome to our next session, Experts Insight short presentations. These Experts Insight have been prepared with VDMA Working Group Additive Manufacturing, and I'm very happy to have 3 experts here on stage which will show new technologies for new applications. Our experts are Maximilian Droppmann, he's Development Engineer Additive Manufacturing at Grobwerke. Tobias Dittgen, Managing Director of Ponticon. Sonja Baumgartner, Head of Business Development of Cubicure. And I think we start right away into our presentations. So, Maximilian, the stage is yours.
Yeah, thank you for introducing me, and thanks for giving us the opportunity to introduce you to our new unique technology. The Grobwerk in Mindelheim is usually not known for AM technologies. We have around about 8,000 employees worldwide. Most of them are doing something different. Some of the applications you can see here. But there's a small group of engineers that developed a new and unique AM technology since 2018. And this technology is called liquid metal printing. So let me tell you what it's all about. Here you can see our first series machine, the GMP 300. It's the first machine that has such a high level of automatization, so you can use it in an industrial environment. Let me explain you how the process works. We have a crucible that is heated, and we feed a wire into the crucible. So the wire melts, and there's a little bath of liquid material, and in this bath there's a piston. This piston is moving vertically, so this movement generates a little droplet that's dropping out of a nozzle at the bottom of the crucible. So this little droplet falls on a build plate, and we move that build plate horizontally so we can build up different parts with different elements and so on. There are overlapping elements possible, so when you have an angle for 30 degrees off the vertical, it's possible to print without supporting structures. If that angle is higher, you need supporting structures. The advantages of the process are, first of all, we use a wire as raw material, so we don't have any problems with other materials considering health risks, need for ventilation, for example, when you use powder, some exhausting system, and so on. No explosion risk. And we have less post-processing work to do, so no sieving and preparation of powder, for example. And the wire is not as expensive as other materials to buy. Then we always say our process is not a welding similar process, but more a casting similar process. We call it microcasting or incremental casting. There's low thermal distortion because we can control the temperature on a pretty low level. Maximum temperature is around about 30 degrees above the solidus temperature, and we can achieve a homogeneous microstructure. Some mechanical properties of the printed parts are even higher in the final state than it is in the raw material. For example, strain rates and so on. Then we have a high flexibility and high productivity. We can change the material real quick, as you maybe saw in the video. We can also vary the droplet diameter. So there's some strategies you can choose. You can use a small droplet diameter. You have more production time, but you can have smoother surfaces and more precise parts in the end. Or you can say you need the part real quick. You take a big droplet, a high frequency. The surface gets rougher, but you have the part in your hands in a very short time. High productivity, we have high build rates. There's a calculated value. We say it's 320 cubic centimeters per hour. We have less post-processing, as I said. And yeah, we have no scaling of the component costs via the filling level. Here you can see some of our applications with different functions. On the left top picture, you can see an application that is supported from the bottom. We have them all shown at our booth C51. You can have a look, and you can even touch them and see the difference between a high droplet, a big droplet, and a small droplet, and so on. We are happy if you visit us. Maybe you have some application in mind. We can discuss how to make it printable on our machine, and we can have a chat and so on. So here's my last slide. It's the machine data. Just to highlight some of it, we have a build space 300 on 300 on 300 millimeters. We have a maximum drop frequency of 500 hertz. And we have different diagnostic systems, camera systems, to control the process and to adopt the process if it's needed. So thank you. That's it for now.
Yeah, thank you very much, Maximilian. I have the one or the other question concerning your new product. It's very impressive because yesterday or the day before, I'm not sure about, I said we must bring more of the, let's say, old or the traditional machine experts and machine vendors to Formnext, and now you are here, so somebody heard my wishful thinking.
Yes.
Yeah, I visited Grob at AMB, so you're a very classical machinery company, but I wonder, do you compare, or how do you compare the new technology with your traditional technology? Do you plan to combine it in a hybrid machine? Because this is just an additive machine, which is, I think, which is very fine. But you're very well in the subtractive area as well. So, is it a new step, and you will abandon the subtractive, or do you want to combine it? What is the strategy behind?
No, there's an idea in the pocket to combine it, because as you know and as you can imagine, there's a drop-based building of parts, so the surface is not very flat. So, but it's like with all the other technologies, if there's a demand that there's a contact to another part, or you want to
functional surfaces,
yes,
something like
and
that,
so on. You always need to machine it in the end.
But may I interrupt you? What is the droplet size? What is the finest surface you can achieve?
The finest surface is like the minimum droplet that's possible right now is 270 microns. So this shape is, you can always see it at the surface of those parts. So in the end, when you use a very small droplet in this size, there's a surface quality of RA 20 microns, round about that. So it's quite smooth, but in the end, if there's some functional areas, then you machine it. And then there's this idea in the pocket to combine the two technologies. Like, it's a perfect match at Grob, but to combine it in one machine.
But in future you will have both. You will have just a machine for 3D printing, maybe one day a hybrid machine, and the traditional subtractive ones. That's a picture. Yeah. Which materials can you process? So are there the standard steel materials, or what is the coverage here?
In the first step, we decided to develop a machine with a maximum temperature of 1,000 degrees. So we can print the whole aluminum alloys. We started in the first step with a 4047, so ALSE12. which has quite high process times. We kind of developed step by step other alloy materials, for example, copper, magnesia, zinc, mangan, and so on. There's always some special things you need to respect, and we're developing it right now. Yes, and so we have a larger field of elements that we can print. Looking in the future, we already have a cooperation with a university concerning printing copper. We also had the first tests on a prototype, which were quite good, actually. And of course, when you look in the far future, maybe there's steel in some time.
So that's a range of materials you were not so busy with in the past. I think it's
yes.
You're gaining a new field of materials as well in your company.
Yes.
Okay, perfect. One last question for now. We can have a chat after the three presentations. What does the machine cost? Can I buy it today?
Yeah.
I have some
the machine costs 590,000 euros, but there's a...
I have to ask my wife.
Would be better. Yeah. There's a exhibition price with 450,000 euros. It's limited for the duration of the exhibition.
Okay. The audience, ask your financier if there is some spare money left. Thank you very much for now.
Thank you.
I'm happy to have Tobias Hitkin here. He's Managing Director of Ponticon, and I'm very curious what you brought with you.
Yes, thank you very much for having me. Let me just grab that part really quick. So at Ponticon, we've developed a technology that we refer to as dynamic material deposition. Essentially, it's a DED process, so we're feeding metal powder through a nozzle, which we then melt by means of laser radiation. The trick that we're doing here is that we're relying on a processing principle where we melt the powder while it's still in flight. I think it's nicely shown on the image on the left-hand side. So the powder interacts with the laser beam while it's still approaching the part that we are either 3D printing or coating, and then arrives on the substrate in an already molten state. And this processing principle allows for very high feed rates. So it enables movement speeds of up to 500 meters per minute from a process perspective. And now, obviously, this is something which you also have to resolve on a mechanical engineering level. And that's where Ponticon comes into play. So we have developed a highly precise, highly dynamic, parallel kinematic system. The machine is showcased in Hall 12.0. It's 11 tons of weight. So this image doesn't really represent how impressive and tall it is. There's 7 tons of granite to the frame, which you need for precision and to compensate the very high forces. We will have a look at some videos in a second. And so as a result, you get a manufacturing technology that is highly productive, highly precise, and at the same time very flexible in terms of combining different materials. This is a result of using the nozzle for feeding powder, so you can do any kind of combination. You can change the alloy composition in real time, and this is a really handy feature, especially when talking about materials for AM, where we believe there's a lot of opportunity and potential in the future. This is the technical background. Let's have a look at how the system works and how it looks like in reality. That this video starts. So I have to mention, this is real time, what you're seeing now. It's 50 meters per minute feed rate right now, and then we're accelerating. In the background, you can see one of the linear drives doing an up and down movement, which is then translated into X, Y, Z by 6 connecting rods. So there are 3 drives on the machine, 3 degrees of freedom, and then you can realize high speed, high precision, X, Y, Z movements. So now we're getting close to the 200 meters per minute. In this setup, the optical system, the processing head is stationary. which is not a very typical approach, but it really helps to get to the high speeds and have the high dynamics. You can see a turn tilt axis on the bottom of the machine, so if we have more complex parts to additively manufacture or to coat, we can change the setup within 2 minutes and then do processing of more complex geometries. So what we just saw is the technology, and then again, high-tech is essentially pointless if you have no applications. So that's what it's all about, and I just mentioned it. We're looking into coatings, and we're looking into additive manufacturing. On the coating side, this is how it looks like. Again, real-time, 30 meters per minute feed rate. I will slow it down in a second so that you get a better feeling of what's going on. You can nicely see the optics in the stationary setup, feeding the metal powder, and then we switch on and off the laser at a very high frequency to only deposit the material in the area where we actually want to create a part. So let's slow it down a bit by a factor of 8 in this case, so you can see the laser just doing a very short pulse for a few milliseconds in this case, then doing the big part in the middle. So there's a lot of know-how in controlling the laser, making sure that you switch it on at the right point in time, that you really hit the areas of the workpiece that you want to hit. Especially in coatings, doing multi-materials is a very relevant thing. So you can do functionally graded materials, you can have a very ductile connection to a part when you do a coating, and then the further you get to the outside, you can include tungsten carbides, carbide particles to increase the hardness. So when we talk about wear and corrosion-resistant coatings, this is a very handy feature of working with nozzles and feeding metal powders through them. On the additive side, and again, I think this is a very nice showcase for the technology because you can actually see the part growing in real time. So we do this circular or elliptic movement. In this case, feed powder mass flow approximately 8 grams per minute. And so this is a nice example of precision and productivity. So this is an aluminum part, 500 micron wall thickness, and print time for this entire thing is just 40 minutes. If you would do it in powder bed fusion, it would take at least 10 hours, and the surface finish is really comparable, if not better. So there was no post-processing carried out on this. And so we can do a lot of work in the additive manufacturing domain as well. Aerospace applications, automotive, robotics, renewable energies. So with this material flexibility, the very high precision and very high productivity, we can enable applications for the first time that industrial end users haven't been capable of leveraging up to now. Hoping that I didn't exceed the 5 minutes too much. Fine. I'd like to thank you for your attention.
That was very impressive. Thank you for bringing us the nice video material to get a better idea. May I lay a hand on your piece?
Absolutely. And sorry for the wrong last slide. It still has the dates of the last conference. Just really.
No problem. The audience, that really looks impressive because it's a very smooth surface. And it's just, you do not see so much, structures of the processing size. But it's a rough structure or a rough surface as well. So what is the minimum particle size you can, or the minimum
layer height?
Yeah.
So this is done with 100 micron layer thickness. Smallest we can do is 30 microns. At the end of the day, it depends on the powder you're working with, and we like to work with powders from 15 to 45, and then also bigger fractions. So that would ultimately define how thin the layer could get.
Our session has a title in the title, the application part. So which new applications do you see coming along with your machine?
Yeah. I think rocket propulsion is a very relevant example. So thrust chambers, where you have 2 major requirements, heat conductivity and then a lot of mechanical strength. So here you need to combine materials, for example, copper-based alloys, nickel-based alloys, and here this capability of transitioning from material A to material B comes in really handy, because you can realize the high heat conductivity on the inside, can go for complex shapes, and then for the mechanical integrity and strength, you would coat what you just 3D printed with a nickel-based alloy, and then do the entire thing in one technology.
Can you give us an idea how long did it take to engineer such a machine? How many years? I don't know.
So we installed our pilot system at Fraunhofer ILT in Aachen in 2019. And back then we did a lot of engineering work, making sure that you could not feel buildings 100 meters away shake because of the very fast movements. All of this is resolved, and now it's more about the software side and getting most out of the mechanical stuff. So the kinematic system and everything is really doing what it's supposed to do. And now it's about enabling the applications on the software side, CAM, environment, and those kind of things.
How many of these machines or plants?
Yeah.
It's a bit more than a machine, I think. Did you already sold?
So we're showcasing system number 4, which we will install at Karlsruhe Institute for Technology in January. So as of today, we have a very strong footprint in academia, and at the same time carry out feasibility studies for industrial end customers. So I expect the first orders from industry by the end of next year.
And would you share the price as well?
Yeah, of course. So with the laser powder feeder, you need some periphery. It's somewhere in between 1.2, 1.7 million euros.
So nothing for me at home as well. Thank you very much.
Thank you.
And we are coming to our third presentation in our session. Sonja Baumgartner, Head of Business Development of Cubicore. Sonja.
Hello.
What have you brought with you?
So thank you for having me here today. I have something different. So I'm talking about polymers today. So as we've seen in the last days, additive manufacturing seems to have overcome most of the traditional issues it had in the last years, so surface roughness and mechanical properties, and also there are a lot of technologies available who try to scale up the processes. But every time you ask industrial customers what they actually need or why do they not yet use additive manufacturing as real production technology, then you always end up with the same 3 things. And the first thing is they want a scalable process, so they really want to use it. So if they want to use it for serious production, it has to be a scalable process, so they don't want to use 100 printers to print 1 part each, but they want to print 100 parts on 1 machine at once. And the second thing is specific material properties. So certain mechanical properties, or like in the conductor industry, so the specific application I'm talking about, for example, flame retardancy or dielectric properties. But the third thing is, and this is one of the most important things right now, is a reliable post-processing solution. Because if you want to go into serious production, you don't want to manually handle thousands or even millions of parts. So this is what we are actually looking at. So what is Cubicore doing? We developed a technology we call hot lithography. So what is hot lithography? We're using DLP and SLA-based printers, but we're heating them up. So if you want mechanical properties which are good enough for industrial products, you end up with resins which are very hard to process. So our resins are very high viscous, and you cannot process them with any other SLA or DLP printer around. So we had to invent a new process how to actually process those difficult materials, as I call them. So last year we, for the first time, presented a scaled-up process for these high viscous materials. It's our Cerion system. You can actually a little bit see it on the left picture there. The build platform is very large. It's 1 meter times 300. So you can actually have either one very large part or a lot of small parts. The problem with scaling up DLP and SLA processes was always that you either have a large bath with hundreds of liters of resin. So you need a lot of resin, and you can more or less throw it away after a few prints. Or you have large platforms, but the platform size are always limited because of the separation forces. So every time you try to lift a platform out of a liquid bath, you have high separation forces, and that limits your size of the platform. So we developed a new technology. You can actually see it upstairs if you want to, where we have a carrier film. This carrier film is coated with resin, with a very thin film of resin, and it just lays down the resin, and while moving over the platform, it's getting cured. So it's more or less a scrolling image, and so layer by layer, it's cured. And so if you want, you can go down to 10 microns of layer thickness, but then it takes forever. So usually we print between 50 and 100 microns layer thickness. And the resolution of the pixels, so we're using DLP beamers, is 50 microns. So we have very high resolution. We have the good surface quality of DLP printing, and we have very good mechanical properties. And so one of these industries which was calling was the connectors and electronics industry, because they were looking for exactly that. Why? Because the connectors industry, they have small parts, they have very complex parts, and they have small batch sizes. So they typically have batch sizes of 1 up to hundreds of thousands connectors. But so nowadays, most of the connectors are customized, so they really need this flexible production, and they also might want to print several this year and a few thousand next year. So they want to be flexible. And so here on this image, you can see a connector with 96 pins. And so an injection molding tool is so expensive and so difficult to produce. So it actually needs more than 1 year to produce a tool for that. But you can print it within 2 hours. So just to give you an example, so one of these connectors, actually the small one on the upper right picture, you can fit 2,000 on one platform. It's printed in less than 2 hours, so we're down to cycle times of a few seconds, 3 seconds more or less. So we're pretty close to injection molded cycle times already. And we have the material properties and the surface quality of injection molded parts. So we really ended up with a process which is ready for industrial applications. And so about the post-processing, so now we ended up with a lot of parts, with large platforms, and you somehow have to make sure to be able to wash them and clean them afterwards. So on the right side, you can see an image of a cleaned platform. So the large platform can be divided into small segments, so it's easier to handle in the post-processing. And the platforms themselves are then put in a centrifuge. So after the centrifuge is already pretty clean, most of the resin is away. And we can also refurbish this resin. So this resin is collected and it can be put back into the system. And then afterwards, it's put into a cleaning plant, which then cleans and dries the parts, and they come out clean and dry within 10 to 15 minutes. So we ended up having a whole process for industrial applications like the connectors industry. And if you are interested in how this process works, just visit us at our booth upstairs, or in the internet. You can find anything you want to know on our homepage as well. So that's it for now. Thank you.
Yeah, thank you very much, Sonja. Very impressive again. I wonder if you say it's a scalable process, and you are talking a lot of the post-processing as well, not just the process itself. A lot of information we get here on stage is just dealing with a key process, and not so much talking about the processes around. So in your awareness, is the automation a crucial part?
Yes, it is, but so automation, so combining those single steps, is then the customer's part. So they usually have in their plans automations. So the customer can decide how to combine these steps. We have to provide all the single steps. We have to provide the material, the printing process, and the post-processing. But what happens in between, if you put it out manually, or if you want to optimize it, then that is part of the customers. Usually they have much more experience in that than we do, so it's part of the customer side.
So are you working on that together with some partners then, or do you really say we are out of the game here?
For the automation?
Yeah.
Yeah, we're working together with the customers, and like we can just give them some ideas how to do it.
That was what I mean. That they are not alone.
No, they're not alone. So if they need any help, we're here.
Ideas how to solve the problem.
Yeah.
Because at the end you said you stressed that it's very fastly produced parts. So it's all about time and cost, and cost and time is sometimes the same. So that's an important step as well.
Of course, yeah.
Can you, these connectors, the electronics industry, they normally, or more and more, they want to have connectors with different materials inside. Can you process more materials than one in your system?
Not at once. So you can always use only one material at once. But what you can actually do is like pick and place. So this process is, you can stop it at each layer and just put, like, for example, inlets or something in. So we tried that already with some connectors. So
then
if
again,
you can put in metal
automation.
parts and then continue printing. Yeah, that would be a part of the automation.
That would be part of it. So I take it from when I have the layer achieved, then I go to the next machine, put in a different material of an inner layer or something, and then I come back to the original process step.
Yeah.
Okay, that would be possible. What else? I have a quick look at our time. Maybe we come together because I have just come here. I have a question for you three. From your point of view, you know, we have three experts here, not talking about your product itself, but if you look a bit from a bird's eye view, where's the technology journey heading from your point of view? That was a question because I had in mind the next question. The automation, is it crucial for the customers, for our visitors here? The cost or faster processes, or we talked about a bit materials, different materials we can process, or innovative concepts bringing, you know, hybrid products. What is the most crucial point, or did I miss any point? What do you think? Maybe we start with you, Maximilian.
Yes, I think the important thing is automatization. As we could see in his presentation, there were 3 axes moving really quick, and I think most of the people and the customers still have some respect from this technology. So if you make it easy for them to enter the technology with a good automatization, you only have a couple of steps. You don't need months of experience to use a machine or a special know-how. Then it's an easy entrance, and if there's an entrance, then the people start thinking in AM. So, and I think that's the first.
So make it easy for them.
Make it easy
to include in their own manufacturing processes.
Yes, yes.
What's your opinion, Tobias, or your most crucial point you see?
Yeah. So my take would be really the economic side of things. If you cannot create a competitive advantage with your technology for your customer, then the technology will not prevail. So it's nice to have this machine and to have this high-tech product. However, if you don't get into the applications, at the end of the day, it's pointless. So I would really encourage everybody in this entire domain to focus on the applications and get it done, and not put your product in focus, but put your customer's application in focus. And yes, you have to do automation, and you have to have advanced software and everything, and those things need to be developed, but they always should be developed with a focus and commitment to a customer problem.
Sonja?
Yes, so actually from my experiences, the next big thing is reproducibility. So we have to make sure that machine to machine is reproducible, so part quality is good. And so automation is part of the process, because if you can automate all the steps,
then you get the reproductivity.
Yeah, it's easier to have reproducible results. But first we have to make sure that the processes themselves, so the printing process, the digital preparation, the printing process, the cleaning process, the material production is reproducible, and then the next step is optimization of the in-between steps, and then you will end up with reproducible part quality. And so I think this is the next step, and automatization is part of that. Yeah.
Okay, perfect. Thank you, Sri, for being with us and for sharing your insights and the new product. You have to work on the costs for me, but I think that's a point in your office as well. Yeah, dear ladies and gentlemen, dear audience here in the room and outside at computers, thank you very much for being with us. After a short break, we will have the next highlight starting Discover3D Printing seminar here, where you can learn some basics of additive manufacturing, and I hope to see you back then here.
And we have something quite suspenseful over there covered in this black veil. Peter, tell us about Stratasys vision. What hides under that veil?
Well, as you know, Stratasys stands for innovation at the end of the day, and innovation also means we are supporting any new technology, especially when it comes to faster go-to-market, faster innovation amongst all the different technologies that we're offering. And therefore we are happy to join forces with Frontier as our development partner, and we are going to unveil a new, let's say, brand new system, which could be explained by Stefan much better than by me.
Stefan, let's pan to you. You're from Frontier, which is I think the heads behind the innovation. Tell us about the technology. This is the future of e-mobility, you teased it. Tell us more.
All right, so what we're seeing here is EULA, and EULA is the answer to a new green and urban mobility, because what we need to do is we need to get rid of the cars in the cities, but how we're going to do this, we need to make a new offering to car drivers, commuters, also in tourist areas. So this is why we came up with EULA. It is a four-wheel bike. It's an e-bike, so you can ride it on a bike lane. It has a hot motor, two hot motors in it. We have a partner for this, so it's very comfortable. It's also a digital device, so it'll have functions like follow me. Like going to have a head-up display. You're going to bring your own device features in there. Wow. So I think that is creating a great deal of comfort and a digital experience for the consumers. I think that's what needed going forward to create sustainable mobility.
Lots of new technologies that hide behind this particular thing, and I hear urbanization is the key word. And since we're here at Formnext and additive manufacturing is the key word here, tell us about the parts that have been manufactured with the help of 3D printing.
What we did, it's an aluminum frame that we welded inside, which you can't see because we cladded a lot of polymer parts on top of it, and all of them were done on Stratasys machines, so we were very grateful for this collaboration. So let me do a sneak preview just for you, because we're going to have a big unveiling.
Let's get that, before the big unveiling.
What you see here is just the front part. The rest we're going to see later.
So basically this is the Batmobile, but sustainable. And from the looks of it, it's going to be a huge unveiling. And I wish you all the best for this technology, and I hope as soon as it hits the road, we are all going to get a good taste of what the future of e-mobility looks like. Thank you both, Stefan and Peter, for talking to us. Have a great time in Formnext, and I'm sure we'll be here for the unveiling. Can't wait.
Thank you so much. Thank you very much.
Thank you. Formnext has the fix for your little craving. Grab yourself a donut today and enjoy what our 3D printing has to offer. We have cafes spread all around the fairgrounds.
Welcome to our Expert Insight Discover 3D Printing Seminar here at Formnext 2022 in Hall 11.0 at our booth here in at the AM4U stage. We have the seminar in cooperation with the Aachen Center of Additive Manufacturing, ACAM, and this seminar is the starting point, which will be continued later here in the hall. So I have 2 points for you. Here in our hall, please make sure to grab a headset because it's a silent seminar, so you just will get the audio when you have a headset over there. And out there at the computers, it's important for you to know that's just the first part. Unfortunately, Formnext today is ending, so I cannot give you the advice to attend tomorrow or something, but maybe you keep it in mind for next year, because next year will be a seminar like this again. Yeah, who is holding our seminar? It's our expert from ACAM, and it's Victoria Krömer. She's our expert here at stage. She's consultant and independent expert at ACAM, and she will give us some answers to basic questions in additive manufacturing. Victoria, the stage is yours.
Thank you very much. Welcome everybody from my side. It's great to be here today. Welcome also to everybody who's watching online. I'm very excited to be here and to explore the basics of additive manufacturing with you today at this Discover 3D Printing Seminar. So during the next 75 minutes, I'll be guiding you through the basics of AM, give you some insights on technologies, applications, and how you can use AM successfully. So I hope you get to learn a lot, and make sure to stop by and ask any questions afterwards. I'll be happy to answer any questions you may have. Just a quick introduction to myself. My name is Victoria Krömer. I am a research associate at the Laboratory for Machine Tools and Production Engineering at RWTH Aachen University, and I'm also a consultant at the ACAM Aachen Center for Additive Manufacturing. I'll give you more information on the ACAM later on, but just a quick sentence. We're a so-called one-stop shop for additive manufacturing, and we offer consulting, engineering, research, and education, all focusing on the additive manufacturing industry. And we're supported by a large community, so we have about 30 partners from industry who together with us work on the challenges that the AM industry has. So what can you expect today? So first we'll dig a bit into the structure of the RWTH Aachen campus, go a bit into the basics of additive manufacturing. You'll get an overview on the different AM technologies, on AM application examples from different industries, and afterwards will come a chapter of how you can successfully adapt AM, and also what the future perspective of additive manufacturing is. And I'll finish it off with a short summary. So why do we in Aachen have such a broad expertise in additive manufacturing? That's the case because we have a very long history in additive manufacturing. So for example, the first basic patent for SLM was filed in Aachen in 1997. And ever since, many different research institutes have evolved in Aachen, each focusing on different parts on the additive manufacturing value chain, building up a broad expertise in Aachen. And all of that comes together in the ACAM, in the Aachen Center for Additive Manufacturing, which was founded in 2015. And due to that, that many research institutes, we are one of the world's most vivid and multifaceted AM ecosystems. So to just give you a quick overview on how the RWTH Aachen campus looks like. So our university was founded in 1870. We have more than 260 institutes that belong to us, more than 6,000 research assistants, and we're a university of excellence since 2007. And what we are trying to do is we want to do applied research. So we want to bring research and industry together and collaboratively work on challenges that different industries may have. So it's always an exchange and development of knowledge between research and industry, and all of that comes together on the RWTH Aachen campus. So the way it works is we have different research clusters that are developing, each of them focusing on different topics. So for example, there's a cluster just focusing on smart logistics, there's a cluster focusing on production engineering, and that structure makes sure that the corresponding research institutes and industries can come together and actively work on specific topics they are interested in. So we as the ACAM, we try and navigate AM complexity. So we create opportunities through research and development, but also training and education, consulting, and agile engineering. So we have a lab space of more than 3,000 square meters to research on additive manufacturing, and we connect more than 100 researchers in the field of additive manufacturing. And on the right-hand side, you can see all the research institutes, either of the RWTH Aachen University or University of Applied Science, who come together in the ACAM. And that makes sure that we have a lot of expertise gathered along the whole AM value chain, and probably, hopefully, have answers for any challenges or questions you may have regarding additive manufacturing. All right, so much just for the ACAM. Now let's dig a bit into additive manufacturing. Probably most of you are at least familiar with AM since you're here at the fair today, but we'll start off pretty basic and just start with a general definition. So there are two norms we've taken into consideration, which is for one, the ASTM 52900, and for two, the VDI 3005. So according to the ASTM 52900, AM is defined as a process that produces components from 3D model data by joining material, usually layer by layer, opposing to subtractive and formative manufacturing methods. And the VDI 3405 defines AM as the manufacturing process where the workpiece is built up in successive layers or units. So we have two components. We have the digital component, and we have the fact that a material is built up layer by layer to form a component. So how does AM differ from subtractive and formative manufacturing technologies? So in subtractive manufacturing technologies, we have a defined workpiece, we have a defined area, and we create a new workpiece by just removing material from that workpiece. So milling or turning, for example, work that way. And then we have formative manufacturing. So we have a given volume, and we form that volume into a new geometry under the condition of constant volume. So deep drawing or molding, for example, are technologies belonging to that area. And then we have AM. And AM works by just stacking volume elements, usually layer in layer, building up a component from scratch. So instead of forming or getting a new component from removing material from a part we have, we just build the part layer by layer. So let's take a look at the global interest on additive manufacturing according to Google Trends. On that graph, you can see the relative interest in both additive manufacturing and 3D printing. The purple graph shows the relative interest in additive manufacturing, and the green graph shows the relative interest in 3D printing. And you can see there's kind of a gap in between those two, which is the reason because additive manufacturing is the more scientific term, and most people know additive manufacturing just as 3D printing. But 3D printing actually is one AM technology, so it's not the correct term actually, but 3D printing is what most people know AM by. And what you can tell is that there's an overall positive trend for both AM and 3D printing. So the graph starts in 2010 and finishes in 2021. And you can tell there's an increasing interest on additive manufacturing and 3D printing. Especially in 2013, 2014, you can see there's a big rise in the green graph. And Barack Obama once said that 3D printing has the potential to revolutionize the way we make almost everything. So there's some disagreement on that statement, because some people say, okay, that's just a myth, and AM is not able to solve everything. It's just a technology that doesn't have the maturity that we need. And then there are others saying, okay, AM is great, AM can solve any challenge that we have. And probably the truth is somewhere in between. So AM is not the healing technology for everything, but AM does have a lot of benefits and potential that, benefit you a lot if you know how to use it accordingly. So that's what we want to explore in the seminar today, what the benefits are that AM can offer for you, and how you can actively use AM to seize those benefits that AM has. So let's take a look on the development of the additive manufacturing market. So if we take a look at the total AM market size according to different reports, we can tell that the market is increasingly growing, and that's been an ongoing trend since the last 30 or so years. So the Volas report stated that during the last 20 years, the annual growth rate of AM was at about, I think, 25%. So you can tell that the AM market is continuing to rise, and it's also forecasted to constantly rise in the future as well. So on the right-hand side, you see many different colored graphs showing the forecast of the AM market. And you can tell that they are kind of diverging. So the purple graph, for example, has a more positive forecast than, for example, the yellow graph. And that is the case because the market is very volatile and uncertain. So there's kind of a diverging trend between those graphs. But what they all have in common is that they predict the AM industry to be constantly growing and also predict a continuous market growth. And the included revenue here from the primary market was AM systems, software, material, and services. So where is AM actually used? So AM is no longer a technology just used for prototyping or just used in one industry, for example. And that's a survey from the Wohlers report. And the Wohlers report asks, which industries do you generate your revenue from? Considering service providers, system suppliers, and third-party material suppliers. And this graph shows that AM is already used in very many different industries. So it's not just automotive or it's not just aerospace, but it's many different ones. So the ones with the highest share are automotive, aerospace, and academia, with about 15%. But AM is also used in medical and dental, for consumer products, power and energy, government and military, and also for architecture. And then there's still a share of about 3%, including other industries that are not named here. For example, the marine industry or others already using AM as well. So what that tells us is that AM has a high potential to be used in many different industries. So no matter which industry you are coming from or what your use case might be, there might be a good chance for you finding a business case or a use case to use AM in your industry. So now that we've learned what AM is and which industries AM is used for, let's take a look at the general AM process chain. So when you're new to AM, sometimes you think, okay, it's just printing a button and then a part gets printed and then you're done. That's a myth and that's not true, because the AM process chain is very complex and very extensive, and it's not just the printing process itself, but it includes pre-processing and it also includes post-processing until you have the final part that meets the part requirements that you have for that part. So the process chain in AM consists of a pre-processing, of the in-processing, and of the post-processing. And it always includes a digital and a physical dimension, since additive manufacturing is a technology including both a digital and a physical part. So let's take a look at the pre-processing at first. For the physical preparation, you need to make sure that you have your material ready. You need to make sure that you have your machine ready and anything else physically in order to conduct the printing process. But then you have the digital part of the pre-processing, which is even more important than the physical part, because you need to have a file, a CAD file, and to make sure to prepare your data accordingly so that you can actually conduct the print job. And then you have to prepare your build job. So you have to make sure that you nest your part or make sure that it's oriented on the build plate and that you set all the parameters that you need in order to conduct that build job. And then you have to do the production planning as well. So and then it goes on to the in-processing, which is where the actual part is physically manufactured. So that's the actual printing process. And on the digital dimension, you have the execution of the machine code. You have to make sure that you monitor the printing process to detect any mistakes that might be going on, so that you're able to react before your part can't be used anymore. And then coming out of the printer, you have the post-processing, which takes up a lot of time and cost of the cost according to the actual part. So depending on the industry, on the part, and on the part requirements, there might be many different steps involved with the post-processing. So for example, if you have a part that was manufactured in a powder-based process, you have to make sure that you get rid of all the powder that you didn't need in order to manufacture that part. And then according to the part requirements, there might be many more steps following. For example, you have to make sure you get rid of supports. There is a heat treatment you might have to conduct, or multiple heat treatments, some surface treatment measures, or also quality assurance measures. And a lot of times when people design their parts, they don't take into consideration that post-processing is also part of the process chain. So it's very important to understand the importance of post-processing and also already take it into consideration when you design a part. Because otherwise you might be stuck with a part that you just got out of the printer, but you don't really know how to post-process it, or you have very high costs with post-processing that bring up the part cost in general. And then you might want to make sure that you evaluate quality assurance data so that you're able to improve your printing process later on. And after the post-processing, when you have the final part, there might be some assembly steps necessary. You have some labeling, packaging, or shipping that you might have to conduct, and make sure that you evaluate your data for long-term improvement. All right, so what are the key characteristics of additive manufacturing? Some of them we've heard already. Additive, we've learned that already, that the geometry is generated by adding material instead of removing or forming. And it's toolless, and that gives us very many potentials of designing very complex forms, because you no longer have to design any complex tools that are time and cost extensive, but you can just print almost any geometry unless it's restricted by the technology. So it's a toolless technology. And then it's digital, of course, because it's based on 3D models. And what shouldn't be underestimated is that it's kind of a complex technology. So depending on the technology that you have, you desire some specific expert knowledge in order to do the design of the part, for example, or to conduct the actual printing process. So now, as the last part of this chapter, I would like to look a bit into the benefits and barriers that additive manufacturing offers for you. And here again, it's important to understand that those are not generic. So depending on your use case, on your part, on your technology, you may have different benefits or different barriers that influence which technology you're deciding for, or that influence which part you actually want to 3D print. But one of the benefits is that you have a very high design freedom. So you can create very complex features, you can use lightweight potentials, or have monolithic part designs where you can get rid of many assembly steps. And then it's possible to have very flexible design iterations and engineering changes at almost no cost and also at very little time. You can do function integration, for example, when you want to include a cooling channel into a part, and just realize very complex functions that didn't used to be possible. And then you can have economic small quantities and individualization, because it comes with almost no cost to just individualize a part, or just have a very small amount of parts that you're printing. You have very short time and idea to product. You can shorten the supply chain by just printing the part near where you actually need it. And you can have sustainability potentials that you can realize through process adaptation or choosing materials accordingly. But then, of course, AM doesn't just have benefits, but also barriers come with it. So one of the barriers is that AM has considerably long printing times. Of course, depending on the technology and on the part. But if you look at a very large metal AM part, for example, it can easily take 24 or 48 hours to print, no problem at all. So compared with conventional manufacturing processes, it has long printing times. But then again, you have to look at the whole process chain and consider the entire lead time. And then again, it might not be that long anymore. A lot of technologies have low surface quality as built. So you might have to conduct many post-processing steps in order to get the part requirements you're demanding. You have pretty large tolerances as built. And additive manufacturing requires what we call an additive mindset. So you need to build up skills and teach and educate your employees in order to be actually able to seize the full potential AM has. And then in some industries, it's hard to qualify additive manufacturing for your parts and to certify it, especially in safety-critical industries such as the aviation industry or the automotive industry. It might come with more efforts in order to be able to certify a part and a process. And then as the last point, I'd like to mention health and safety measures, because according to your technology and material you're using, you might have to make sure that you that you protect your employees accordingly. All right, so much for the first chapter. What have we learned? We have learned what additive manufacturing is, how AM technologies work in general, and we've taken a closer look into different advantages and disadvantages, and it's important to understand those in order to be able to actually decide which technology you want to use. Is AM something that's good for you or that maybe doesn't fit your use case best? So it's important to keep those in mind when we move on. So now I'd like to move over to an overview on additive manufacturing technologies. And for those watching from online, probably I won't be able to finish, but I'll just give you a quick glimpse into technologies anyway. So which technologies do we have that are established? There are many different classifications of additive manufacturing technologies. Sometimes they're classified according to raw materials, sometimes they're classified according to the energy source, to the material deposition principle. But here we have oriented ourselves along the Formnext field guide and also the ASTM terminology. And what we can see here is that we have 5 big groups of metal AM technologies, which are powder bed fusion, direct energy deposition, material extrusion, binder jetting, and material jetting. And those differ for once in the terms of raw material, but also regarding the deposition principle and the energy source that's being used. So on the left-hand side, for the powder bed fusion processes, we have it's a powder bed-based process. So in a powder, we have a chamber where powder is deposited layer by layer and then selectively fused, either through a laser beam or an electron beam. And then in the middle part, we have direct energy deposition. And differing from the first principle, we don't have a chamber with powder, but we just apply the material in the same time that we insert the energy source. So the material is fused at the same time when the energy source is being applied to the substrate. And then we have material extrusion, where we have a metal filament that's being extruded through a nozzle and needs to be sintered afterwards. The next category is binder jetting, which is also a powder bed-based process. But here we have a binding agent by fusing the powder together, and the parts need to be sintered afterwards. And then the last category here is material jetting. And then if we move on to the polymer AM technologies, we can see there are different categories, of course differing a bit, but we have the powder bed fusion processes there again, where we have a powder that's being fused either through just an energy source like a laser or fused with an agent and then energy is being applied to it. We have also material extrusion processes where either pellet or filaments, polymer filaments, are being extruded through a nozzle and deposited, stacking up the part layer by layer. And then we have material jetting, where parts are cured with UV light, and also we have photopolymerization of resins, where either the resin can be cured with laser or with a projector. So I would like to take a deeper look into the different technologies. I'm not going to be able to cover all of them, since I don't have enough time, but we will take a closer look into the ones that are green on that slide. So laser powder bed fusion, laser metal deposition, ELA, and binder jetting. So now let's take a closer look at the laser powder bed fusion, which is, like I introduced earlier, one of the powder bed-based processes. So as input, you have a digital model and you have metal powder, and then a layer of powder is deposited exactly in the same layer height that you want your height of the part later on. And then a laser beam selectively melts the parts of the powder that you would like to fuse. Then the build plate is lowered by one height, and then the whole process repeats itself. And laser powder bed fusion is the powder bed or the metal AM technology that's most established in industry because it has very high technological maturity, and you're pretty free in terms of materials. So almost any weldable materials can be used for laser powder bed fusion, such as, for example, steels, nickel alloys, aluminum alloys, copper, titanium. So you have very free choice of material in laser powder bed fusion. One disadvantage is that you need to make sure that you tie the parts to the build plate due to stability and heat reasons. So you have to make sure that you use support structures to tie the parts to the build plate, meaning that you can stack the parts free in the build chamber, but you can only stack them on a two-dimensional level. But advantages, again, are that it has very high technology maturity, and that you're pretty free in terms of design and also material you're using. Now I'd like to move on to the second category, which was the category of direct energy deposition. And the process shown here is laser metal deposition. As input, you have again a digital model and metal powder, but there are also processes that are wire-based. And the way it works is you have powder that's supplied in an inert gas flow, and you have the laser beam meeting the powder. So the powder is solidified the moment that the energy source meets, stacking up the part layer by layer. And that technology is used a lot for coating processes and repair processes, because you can just use it to fix the parts of a component that might need some repair, for example. And again, it also has general suitability for weldable materials, so you can use steels, for example, nickel base, or aluminum alloys. And an advantage of laser metal deposition compared with LPBF, for example, is that it's way more productive. So you have a way higher deposition rate compared with laser powder bed fusion. But at the same time, you're not as free regarding the freedom of design, because you can't produce any part components. You're limited in terms of overhang angles, for example, or angles in general regarding the part. Just checking if I have more time left. Okay. And now I'd like to go a bit deeper into the ELA process. I'm not sure if you've listened to the speech earlier before where Ponticon was here. So you've probably learned some about ELA already, but ELA is the same process principle as laser metal deposition, except it's only suitable for rotationally symmetrical parts. And it's also used for coating processes, and has way higher speed than laser metal deposition. So yeah, it can provide extreme high speed. And ELA is a technology that has high potential, so it's an emerging technology also in industrial applications, and I'll come back to ELA later on as well. So now the last technology I would like to consider is binder jetting. So in binder jetting you also have powder, but that powder is being fused through a binding agent. So you deposit your powder, you apply the binding agent, you cure the powder, and then the build plate gets lowered, and the process repeats itself. So after the part is being built, it's in a green state. It's very fragile, and you need a lot of post-processing steps for it to get its final part requirements and make it work. So for example, you need curing, sintering, you need the depowdering to make sure that the parts leave their green state and become very stable parts. Compared with LPBF, binder jetting has lower technological maturity as of right now, and has less materials that are qualified, but it has high potential for higher productivity, because in binder jetting you don't need support structures. You can just nest the parts three-dimensionally in the build chamber, which gives you the opportunity to place many more parts in one build job, making the technology more productive compared with LPBF, where you need support structures and can only nest parts on a two-dimensional level. So now, as the last step for the ones watching online, I would like to take a closer look into the metal materials. So according to BCG, there are 8 groups of material that can be used for metal additive manufacturing technologies. And it's the same as in every manufacturing technology. You always choose your material according to your application. So for example, if you want to have a part that needs to be corrosion resistant, stainless or tool steel might be the material choice for you. And then you always have to make sure that the material you're choosing matches the technology you like to consider, because not all technologies work with all materials. And generally spoken, you can say that materials for additive manufacturing are more expensive, way more expensive than conventional technologies. For example, for powders, you can easily pay more by factor 10. And a lot of machine manufacturers restrict users by saying they can only use the materials they themselves have developed, because otherwise you'll use warranty, for example. So the market for third-party materials has been very limited thus far, but there's a positive trend that can be observed. So the machine manufacturers are opening up. There are more open systems, and it's becoming possible to also use third-party materials for machines instead of having to buy the materials that a machine manufacturer is providing. And now I think it's a good time to make a cut, I guess.
Yeah, perfect. Thank you very much, Victoria, for this insight. And thank you very much for the audience to listen here to your seminar. Yeah, well, there will be a break in the live stream until 2 p.m. The second part of Victoria's presentation will continue here in the hall, again as a silent seminar. Yeah, dear audience, we will see each other again at 2 p.m. here in the hall. Then Michael Kieran will give insights in textile series production with additive manufacturing. A very interesting topic again. So, see you later at 2 o'clock.
I go. Should I look both ways before you cross me, baby? 'Cause I don't break for boys. I'm moving on. For miles, 67 fastback, oh, it's just my style. We're headed down, down, down the road. Just enjoy the show, watch me as I go. Should look both ways before you cross me, baby, 'cause I don't break for boys. I'm moving on.
Hello, ladies and gentlemen. Welcome back here on the AM4U stage. I hope you enjoyed lunch. And I can tell you that you really can look forward to more highlights here at the AM4U stage on the unfortunately last day of Formnext 2022. New applications, innovations, new ways of creating and developing material, details on interesting markets. We have already covered a number of exciting topics here on this stage. And that's not the end of it, because in the next Expert Insight, we're looking at an industry that is not primarily in focus when you consider industrial applications in additive manufacturing. We will take a look on additive manufacturing in textile series production, and the person who will guide you through that topic is Michael Kieren, Product Manager Business Development of Karl Meyer Stoll R&D GmbH. Michael, welcome on stage. The stage is yours.
So, thank you, Sven. And thank you to get this possibility to presenting our project and the tests, what we have done to combine the textile industry and the additive manufacturing to bring these two industries together. So my agenda, at first, I will take the chance to give you a small impression what is Karl Meyer doing, who is Karl Meyer and what we are doing, and then the next step will be our project, 3D printing on textile. So who is Karl Meyer? So we are a group with German roots, so we are roughly 3,000 members worldwide. So our main business is creating textile machineries and everything around. It means blend manufacturing, for example. So we have worldwide 18 locations all over the world, based there where the textile industry is. So that means we have around 90 countries where we have agencies and locations. So we are family owned and founded from Mr. Karl Meyer in 1937. So Karl Meyer Group, you see, We have different business units. The biggest one is taking care of the machinery. Then we have electronic goods. We have digital solutions for sure, which we're using for our textile machinery. And the field of new business and beyond textile. That means we are looking as well in markets which are not belongs directly to the textile industry. So our main business, for sure, you know, textile industry is based in Asia. So that means we have there 74% of our market is in Asia. We have also a strong market in Europe and in Eastern, like the Turkey market with 21%, and in 5% with the American market, for example, in Brazil. So here you see our nice headquarter in Obertshausen. This is near of Frankfurt, roughly 20 minutes from the airport, where here we are located. This is the main area. You see we have roughly 600 million euros in total revenue. This is numbers from 21. And what I say, around 3,000 members of our Karl group. Here you see our locations, where we are. What I say, that we are based on the Asian market. That means we have in Changshu and in Hong Kong. And Changshu is one of our biggest plants in China. This is between Nanjing and Shanghai, between the middle. So in Obertshausen, this is our main location. Then we have in Chemnitz, in Selbitz, also in Frankfurt we have one location, where is KM-On, our company who is responsible for the digital solution. In Reutlingen, Waldmünchen, in Mezzo-Lombardo is also one location, in the near of Milano. In Switzerland, England also was famous for textile industry in England. Dakar, it means Indian, also in a good market for the textile industry. Ahmedabad, Delhi, and not the last, but here in this presentation, the least is Fukui in Japan, a small facility who takes care of, we call this double needle bar business. That means for spacer fabric, for seamless fabrics, which you know maybe out of the shoe industry, sport shoe industry, the three-dimensional textiles. So what we are doing, so what I say, textile machineries. So maybe you know flat knitting, maybe you know weaving machineries. So what we are doing, we call this warp knitting, and this is mix between weaving and circular or knitting, for example. So that means here we move the complete needle bar. This is very strange maybe for people who comes out of the additive manufacturing, but this is a knitting technology who allows you to define elasticity or stability of the yarn in, I would say, in near of each direction. So the part of flat knitting, maybe you know some shoes, sport shoes with this very soft and fine shoe uppers. So this comes out of the flat knitting industry. Then we have technical textiles. Technical textiles means for us that we are here in a part of industry like the windmills, for example, and the car industry. Here we are using carbon or glass fibers to produce a very high tenacity body of a car, or for the windmills, that means an offshore part, for example, or on the land side. To complete this, we have one business unit who takes care of the warp preparation. Warp preparation means, so we have in the first step in the textile industry a single thread. For our industry and as well for the woven industry, you need more threads beside. That means here we bring these yarns, which are presented on a bobbin, we bring on these machines that we warp this on a warp beam, so we call. Then we have our part of digital solution. That means here we provide our customers dashboards for the textile industry, that they see the efficiency of the machines, that they see this the production running, but also for part of sustainability, that they see that there is no waiting time or something else who waste energy in this process. Electronic components, so also here we're producing chips, mainboards for our machineries, which we are using in the warp knitting and in the flat knitting field. So here you see along the textile chain, starting from the material production over the yarn up to the reuse. So we are here in the middle. That means in between the yarn, the warp preparation, the fabric, and the product. It means, for example, in flat knit, here we are able to produce ready-wear garments. That means pullovers, for example, which you can wear when they comes out of the machineries. So here some examples. It means on the left side you see this nice young lady with yoga wear, for example, very famous. And in the middle, these shoes. I'm talking very often about shoes because this is a very innovative market for us. You see there the possibilities with high-low effects, with coloring, which we are using here for brands like Adidas, Puma, or all the others. On the right side, you see is a picture with this technical application. That means a cover for a truck, for a camion, which is a very good example for this, or for outside advertisement as well for this. So now you think additive manufacturing and textile industry, how it fits together. So we started roughly 4 years ago with our project. It comes that we looking in this industry, or that we looking in the newspaper and see written down there's that you can print out your textile, your personal item in the next few years. Where you say, okay, this is not so good, then nobody needs a warp knitting machine. So what's happened? Let's have a look. And then we look in this market and we see, okay, there is a lot of possibilities, but that you can print out your pullover, your trousers, or something else. I think it takes a bit longer than these 2 or 3 years to achieve this. But then we see that these technologies which comes out of this additive manufacturing is high flexible. So you use it for prototypes and all these things. And we say, how it fits to the textile industry, that we bring this high flexible of this additive manufacturing to the high efficiency of the textile producing. And then, so we test a lot. So we collecting some experience, that we test what's behind laser sintern, what's behind laser melting or stereolithography or FDM. So because we are looking for an industrial process, it means at least our machines run 365 days per year, if possible 24 hours. So that means when we are looking for a process which we can integrate in this textile chain, then it must be a process who is able to fully fill such requirements. Then we checked out what is possible, and then we start to create a process that we find out there are technologies in this additive manufacturing, like to print out 2 components, for example, then you need no temperature at the fabric, because this is also so a critical point when you want to integrate something in a textile process. Because in our machines we are working with roughly 98% with a chemical fiber. And when you have temperature in this process integrated only on one part, it's very dangerous, because then you see a presetting. It means that the fabric starts to change a bit. And this you see after this complete finishing process, which you need for a chemical fiber. Then you see this inside the fabric as a failure. And this, we can't accept it. So then we test. Now you see a bit more about our prototype. This is the last one. But we test some substrates. That means starting from this laser sintern, that we try to bring this laser melting directly on the surface, on the fabric. But then we see, laser, it's a good process, very precise process, but what's up when this machinery starts working? So we have vibration on the machinery, looks not so good. So let's try out another one, and then we stay at this process, what I tell to you. This is these two components. So that means we have integrated this printing desk directly as an inline process in the textile machinery. But I have also to say that we can use this as well as a roll-to-roll process. Here we found out that in some cases it makes sense to integrate this process directly in the textile machinery. That means when we can control the tension of the fabric to bring it to this printing desk, then it makes sense when we use this pre-tension, because these are all numbers which we know from the textile process, to bring this in the textile process. If you have a quite standard fabric, for example, then it's up to you if you're using directly on a textile machinery, or that you use this as a roll-to-roll process, what makes it much more easier, because you can make all these processes which you have in front, you can do it in front. It means coloring process, stentering, all this finishing for a textile, you can do in front, and then you can print on this system. So what we see then, that this is a very flexible process. It means for brandings, for reinforcements directly on a shoe, for example. This is very helpful for us. And this means for us, we can use this in each of our machineries. And even more, we can use it as well in different other technologies like circular knitting or the woven fabric. It means here we are completely free what we are doing with this. So here you see the result. I hope now it works. We check. No, doesn't work. It's a movie included where you see how it works, that we print it out. But these are now the numbers of our printing desk. It means we can print in X, Y, and Z direction, or we can move this printing desk. So we have a motion speed of 5 meters per second. It's only the motion speed to positioning the printing head over the textile, because we are working with a standard working width of our textile machinery with 138 inch. That means more than 3 meters. And we want to use only one printing head at least on this machinery, and here we try to position this system very fast over the complete width of this textile. So printing speed, we calculate that we can achieve with this printing system around 85 square meters each hour. That means not that we print over the complete width and cover it. So it means that we have some applications which we print on the textile. That means here it fits to the production that we say around 85 square meters each hour is achievable. If you have a small swoosh or 3 stripes or a small raptor animal on top of this surface, which you print then on a shoe, this is achievable around this number, what I say to you. So we have integrated a camera system to position this printing head. So this is very important, because you see this blue shirt, we have there some areas. This is a jacquard patterning in our textile, which shows you the areas from the shoulder part or under the arms where I have different structures. It means it can be more open, more closed. Also that we're using this for sampling. That means that we bring some patterns on top that it looks a bit nicer. And here we try to combine these two technologies. That means we take its database, this information which we have for our machines who are producing such a fabric. So we take this and can mark with a different color the parts which the printing head has to print on it. So this is our camera system which we are using there. Then we have what's very important, also we make there so much mistakes, is that we have this moving belt for tension-free transport of the textile. This is very important, that we're moving this textile forward for this inline process, that it doesn't have any falls or something else on top, that it lays flat and moves in one direction in this way, that we have no crinkle or something else inside. When we have some crinkles or some up and lows on top, so it's very dangerous that this nozzle. Okay. Microphone.
Break. It was too fascinating, so you reduce all the batteries. So keep on going.
Okay, now it works. So, okay, now it works. Friday afternoon, also Technic has time for a weekend. Okay, yeah, so where is that? So we have now printing area. Printing area of our prototype is 2 meter by 1 meter. It's only the prototype. What I say that we have calculated this complete system to a width of 138. I think we stay with these 2 meters because this is time enough to print on this fabric. So the next, here you see this is the first prototype which we are producing was only it works in linear, like an old printer. This was the first one, but here I can explain you. Here we test all the materials which we have tried out. That means we start with these materials which are known in the textile business. That means we are using polyurethane. Then we have silicon systems, and what we have done as well is a conductive paste which we are using to print on a textile, to realize these smart textiles or these variables. Maybe you know this, for example, to collecting the heart rate, or that you see the breath of your body for sportmen. So polyurethane, what I say, very famous in the textile industry, especially for the shoe industry, and big advantage. It's a polyurethane. It means it fits to what the brands are looking for. It means part of sustainability, that you are able to recycle the shoe because it's produced in one material. The sole is polyurethane, the shoe upper is produced with the thermoplastic polyurethane, and then you print with the polyurethane on top for all these applications and for the reinforcements. Then you have a shoe out of one material which you can recycle. So silicon, also very famous. If you think about bras, women bras, for example, or here you can use this silicon to make it more stiff. Then you can wear it on directly near of the body, that it feels more comfortable than the polyurethane. And the conductive paste, here we have combined with another project of Karlmeyer. This is the textile circuit. Here we're using a technology which comes out of the lace production, of the women lace production, where we position very precise threads for laces. In this part we're creating flowers. So we substitute this fluffy yarns to a conductive material yarn and position not flowers, so we positioned some conductive circuits to using as a remote control, or as well to collecting signatures from the body, heart rate like this or temperature, to present this on a screen or in this shirt. To have more possibilities, because we use this thread on this part, it means we are limited where we can position the threads. To make this more or less unlimited, we're using this conductive paste to combine these two technologies. One to position the conductive threads, and the other one to position with our printing head this conductive paste to give more support to the textile. So, advantages. So, some I've explained. So, higher efficiency that we integrate this directly in this textile process. It means it's more flexible. For us, is it very important to be flexible because the designer, for example, thinks, okay, I want to have there a red thread, or I want to have there a mark, a sign, or something else. This is, for the textile industry, very heavy to integrate this in a standard process. And we are lucky to use exactly such a technology to make this more easier, to make it more flexible, to have more shorter reaction time directly to the market. Means as well that we try to reduce the complexity of this complete process. So that means from the designing to this part of that you have a textile in hand takes some weeks. If we combine this with such a technology, it can be that it takes only some hours that you see the first draft of your mock-up or of your sample. Individualization, well, hard word, sorry for Friday afternoon. Also very important to use this. It means you can buy your shoe with your name, or you can buy a shirt for your soccer team, which is not professional. That means you have more possibility to creating your own design. Can be as well that we have a storage for designers, which they can use this to make a small collection. So then for sure that you have some reinforcements to protect some parts of the shoe, or that you have, especially in sport shirts, the possibility to support the body for a movement, like a golfer, who makes all the time the safe movement, that you teach him or to squeeze him with such a technology in the right movement. It means when he made something wrong, that he feels, oh, it gets stiffer or something else in this direction. That means more and more possibilities which we can have with such a technology. Here you see our camera system. I think we need more at least than 2 cameras for the positioning, because the textile has in some cases an own life, that you see differences between the right side and the left side, so this we have to control. Also here we learned a lot, that we try to make, for example, a shirt that we print on the left side, and we integrated directly the right side, and the printing head is working, and then we see left side perfect, right side doesn't fit. But it's the same sample, why it doesn't work? So, and then we see that there are small differences, because this was a finished fabric, that we see small differences between the left side and the right side, and here we have to correct the position of the printing head. So how we can do this? So we, using the printing head, that he's going to the position, or first we start that the camera system realize, oh, okay, this is my sample, which I have to print. We have a small database that he see, this is my sample. He see, here I have to print in. And then he's doing 3 positions. I mean, he start at the highest position where he starts to print, position the printing head, and then he go to 2 different other positions. And when these positions are correct and the camera system has realized this, then he starts to print. When it's not correct, then he stops the print. As well, when this sample or the shape which we integrated in this textile is not straight, or it's how to say, it's not the origin. It's from the shape a bit not correct. So also then he realized, and then he stops directly. So here we use as well for quality systems. So also we have the possibilities now. I talked all the times about sports shoes industry, but also for industrial fabric, that we can integrate here like buttons or something else. It means a bit higher printings in the sports industry or for the textile industry, we talk about a thickness of at least maximum 5 millimeter. If we go in this industry, like the automotive industry, where we can create some buttons or some holders, for example, rooftop lining or the door panels, here we are able to print as well in a higher region. That means up to, in our system now, limited with 1.5 centimeter. Yeah, reinforcement areas for muscle support, also known, or tell to you, these are possible. So, in the background you see this small shoe. So we presented this at the last ITMA show. ITMA is a huge fair for textile machineries, and here we try to show the future of a textile, how it can look. And here we're doing what I say, that we use the tension or the pre-tension of a textile and print with a stiff material on top. And when you cut out this pre-tension textile, the print stays stiff, and then it moves in the next direction. It means you're creating a three-dimensional textile directly with this print out of the machine. Makes it absolutely interesting to use this, for example, in bra parts. It means women's bra, for example, or like the shoes, to creating more functionality for parts like the shoe industry. To this application, we have a lot of possibility. We try a lot, and at least we're looking for this application where we can use it, and we are looking for partners who is willing to walk this way with us. This is the reason why we have, together with 2 institutes in Germany, created a platform that we have a conference which we try to bring these 2 industries together. The textile industry on the one hand, and the industry of the additive manufacturing of the other hand, that they are talking together to creating this benefit, or also to creating this not a showcase, to creating the serial production. Because we think that this is the most important thing, that we provide technology, that we provide benefits for customers or for end users. And I think this is very important. This is the reason why we're creating such a conference. So yesterday, I can say, this was the 17th November, so we have the conference now the 5th time, and it was a very good conference with a lot of talking in between parts of material side from the additive manufacturing parts, for FDM printers, up to stereolithography in combination with the textile industry. And it was so impressive that we're starting now to different other projects who based or who comes out of such a technology. Makes it very interesting. So we are talking as well to the fair Formnext, that we try to integrate this format a little bit inside this fair to get more connection point in between. So yeah, also once again you see the application inside the technical textiles, this reinforcement for the side door panels, headliners, all these things I have told to you. So additional application, for example, is also the electronic industry, that we can cover, for example, computer chips, or we talk about this wearable part, this part of smart textiles. So it means you have electronic components directly integrate in your clothes to cover this completely. That means you make it washable, for example. It makes it more comfortable to wear it on the skin, only as an example. Also areas for steering function. These are the applications that I told to you when you are a sportsman and you make some movements that this structure can support to you. So, I think I'm finished with my presentation and hope it was very interesting for you. Here my contact data. Visit our website. This is the Textile Makerspace. So Textile Makerspace, we're creating our own website because this is a bit outside of this traditional of the textile machinery. Normally we present only things which you can buy. This is a prototype who is not saleable currently. This is the reason why we're creating this Textile Makerspace, where you see all the new things, what we are creating, which we have in mind to give our customers or our cooperators very early to bring them on board to operate with them together. So, thank you for listening, and I'm not sure that we have some time for questions or...
That's a good thing, to be honest. First of all, thank you very much. Applause, please, for Michael here on stage. Michael or Michael, very interesting presentation. I must admit, you don't know before, because I'm a big fan of function wear. And if you see the development of the last 10, 15 years, what has been worked out, and wearing compression socks all the time, for example. You mentioned, for example, the changing stiffness of parts of the, let's say, take a shoe or a shirt or whatever. How far are we away from my individual shirt regarding the needs I have? Let's say I have ankle problems, and it's not about a medical sock that I need, but more like, you know, you develop something that has a certain stiffness change when it comes to a certain angle. Is that something where you're working on actually already? And when can we expect that? Sorry for that. I know you get the question quite often, but I'm an end consumer, so I could be a customer. Right.
So I think it's not so far. If I look around here on this fair, you see all the components which you need to get exactly this. It means you have 3D scanner where you get your image of your body, and then it's very easy to transfer this to our printer.
Yeah.
And then we have the goal. It means we can combine the textile which you wear with the stiffness or with the functionality of these things what you want to have. That means this personal item, it's not so far. I think
the thing is, I mean, you started your presentation remembering that you said for our target is that the machines are running 365, 24 hours a day, all over the year. You try to get as much volume out of them as possible. So then I make a switch, and I'm Sven, coming to Karl May and say, sorry, Michael, I would need my function wear. I mean, this is from a cost perspective. My shirt would then be what, 2,000 euros or something like that, in order to do it. So you need that scale.
Yeah.
So we were talking about prototyping, make a cross in the box, but how far if I want to have like 500,000, which is still a quite low number in your industry, these volumes, how's that?
So this individualization and the manufacturing, the serial production, it's also a very good combination that we're creating this mass production. That you have set one machine with a sport shirt, and then you bring your data to this machine, and not only you bring these data to the machine, that you have a cloud of interesting people who bring also their data to this machine, and then you have a mass product. That means then you are not alone.
But is that feasible?
Yeah, for sure, for sure.
No, I mean, imagine, I remember like pretty much 20 years ago, I worked for Heidelberger Druck, and we brought into the market the digital printing, like where the first time when you want to create a magazine, for example, you could print each and every magazine different than the one before, which was impossible for, I don't know, 300 years, okay? So now getting to the clothing, and like all of us are ordering shirts at your facility, and each and everyone wants another logo or initials on, and you can print it on the go?
We can print it on the go, or we can integrate it as well in the fabric themselves. That means with the checkered system.
Yeah, incredible.
We present this, it's now 4 years ago at the last ITMA show, that we have made pictures from customers who visiting our booth. We make a picture, and when it was allowed to run the machine, because they have only a small time schedule where you can run the machine, and then we bring it directly on the fabric. That means then you have your face directly on the fabric. And then you can combine this directly with your print to make it more individualized.
So let me give you feedback. Friday afternoon, we are close to the end of the fair. You still excited me, and I think all in the audience. Thank you so much, Michael, for being our guest, for introducing to the topic, and good luck for the future.
Thank you.
Looking forward to
you.
your products. Michael Kirn, ladies and gentlemen.
Thank you. Bye-bye.
Yeah, after this very interesting session, we are heading on with our program. And as I already said, we are getting closer to the end, which is quite sad, but we have still some highlights to come. And the next highlight will be presented to you right after some insights and impressions here from the exhibition. So stay tuned. We will see us back here in about 4 minutes. See you.
Julian, we're here at Siemens, and in front of us this incredible piece of technology. Explain it to us, how does this all work?
So it's amazing to have you here on the Siemens booth. What you see here is an electronic assembly for iWatch cases. And basically what we are showcasing is how to use additive to improve the efficiency of such a factory in every industry in the world. So we are talking about this part here.
Yes, and we have an approach that we have a digital twin of this whole machine and production line. And with this digital twin, we start into NX and start redesigning the part. First of all, we are lightweighting the part up to 60% lighter than it was before. Secondly, we optimize the design. If you just hold it together, maybe we have a topology optimized design, which is also enabling the part to less energy usage on the machine.
So Serene, you spoke about the lightweight quality of the prototype that you have in your hand. Talk about the support structures that you use in this technology.
So support structures are a thing you need for several technologies in additive, but in FDM it's most challenging, but also most efficient to use less or no support, and that's what we realized within this design. So we added chamfers, analyzed the part and its functionality and functional elements, and then realized the supportless design. Even in this hole, you can see like a chamfer here as well, and that is enabling us to print this part without any support.
Thank you, Serene and Julian, for talking to us and for the great demonstration. Have lots of fun in Formnext.
You too.
Thank you.
I love Formnext.
Formnext is for us really a great pleasure.
This is my first time at Formnext actually, so it's almost overwhelming. I mean, just the magnitude of it. Everybody's here. I'm really excited
to network, to learn about the new development of technologies, and really be like a sponge to absorb new knowledge here today.
This is the place to be in our industry. Everyone who has something to say in additive manufacturing is here.
I like Formnext. This year is incredible. We are in a big booth together with Desktop Metal family. A lot of people, friends, partners, and we enjoy a lot.
And what you can see is that we have a very mature market at the moment. So those questions are on a much higher level than in the previous years. The contacts are of a very high quality, and this is really a lot of fun.
The crowds, the people, the energy, the enthusiasm, the exhibitors, the visitors, everything about it. This is a candy store for us young kids who love technology and getting our hands on parts. So it's you cannot be at a better place in Germany in November.
So who cannot love Formnext? That's the question.
Hello and welcome back, ladies and gentlemen. Let's round off the day with an overview of the highlights of Formnext 2022 in terms of technical innovation. We were able to win an expert for this who can give us a very good assessment with her know-how. What's new in 2022? A summary of the key additive technology innovations at Formnext. Welcome with me on stage, Alex Kingsbury, industry consultant, additive economics, fresh from Australia. Alex, please come to me on stage. Good to have you.
Thank you, Sven. Hi everyone, my name's Alex Kingsbury. I've worked in, and apologies, you're gonna have to forgive my voice. It's terrible because it's Friday, of course, of Formnext. So we're all exhausted. Thank you so much for being here with me. Like I said, my name's Alex Kingsbury. I've worked in metal additive for about 10 plus years. Also worked across a number of different industrial polymer systems as well. Like most of you, I've been doing the rounds of the halls, having the meetings, seeing the booths. And what I'm hoping to give to you today is a bit of a summary of the highlights of what I've seen. So here we go. I'm not going to have any slides today because I wanted to really come into this with the freshest impressions that I had. So I thought it would be best if it's just you and me here talking about what I've seen at Formnext. So to kick it off, sustainability I thought was a really, really strong theme. We've seen this through the course of the year, I believe. It's obviously, 3D printing has always had a play in sustainability, but this has come through very, very strongly in 2022. In terms of what's driving that, I think it's probably driven by a lot of government regulations, but I think it's probably more driven by companies forecasting and getting ready to be able to report on things like environmental, social, and governance metrics, right? That's going to be increasingly important. So I've been having a conversation with Sherry Handel from the AMGTA, the Additive Manufacturers, the Green Trade Association for Additive Manufacturing. Sherry said to me, show me a 3D printing company and I will show you their sustainability story. It's Sherry's belief that there is a sustainability story for every single exhibitor here on the floor. I think it's really important when we think about 3D printing that we don't greenwash, right? And the way that we avoid that is by doing something called a life cycle assessment. And we've seen a couple of these announcements come out this week around doing life cycle assessments. So for example, I'll give you one. 6K has just recently announced with Fraunhofer ILT that they're going to be doing a sustainability assessment on their process. That's a really interesting company. They have an atomization technology or a powder production technology. And in titanium, they have actually bought a recycler. So they get titanium scrap in, they can mill it, and then they spheritize it. And you can use that powder in metal powder machines, in laser powder bed fusion machines, e-beam machines. It's a great sustainability story, and of course, you just look at that anecdotally and say, well, that sounds very sustainable. It sounds like it has a much lower carbon footprint. But the way that you evaluate that properly is by doing something called a life cycle assessment. So I think it's really great to see that they're going to be doing that with Fraunhofer. Also around sustainability is very interlinked with supply chains, right? So we're having a look now very critically across all of our supply chains. I think everyone here listening today has experienced, I know everyone here today has experienced supply chain pain in some way, and of course 3D printing can come in and address that solution really, really nicely. We had something called AM Forward announced in the US earlier this year, and that's all about being able to ensure that you have supply within your own country. Why do I mention supply chains, though, with sustainability? They're interlinked. They're interlinked. Okay, so the longer that we're going to be sending something, the further the distance, the higher the carbon footprint. 3D printing is an amazing technology for being able to address supply chain demands and squeezes. It's also really important for things like national security as well. Every country now is going through a process of looking much more internal to how they can cater for and be able to produce the things that they need within their own country. Additive manufacturing is an enabling technology, and it is a perfect technology to be able to address some of these issues that we have around supply chains, sustainability, and national security. I mentioned 6K. We also have another company here exhibiting for the first time called Metal Powder Works. Similar sort of idea in that you're using a billet and it could be scrap, and you're able to then process it to produce powders. It's a much lower energy cost to produce those powders than your traditional gas atomization. And they did a life cycle assessment as well, again, with an independent, verified supplier of life cycle assessments. And they found that their process was 90% lower carbon footprint. Okay, so we're starting to see a lot of this sort of behavior and talk coming out in the show. It's one thing to, like I said, talk the talk. You're going to walk the walk as well. And doing things like engaging with the Green Trade Association, engaging with organisations like Fraunhofer, doing things like life cycle assessments, that becomes really important in order to claim your green credentials and to properly report on your environmental, social and governance metrics. We also have, I guess, the issue around metals being much more inherently recyclable than polymers. And I think that this is something for the industry to consider more generally, is how we treat our recycling in terms of material supply to part production to then what happens to that part at the end of its life. And we can see that we have a much more transparent process or end-to-end life for a metal part than we do, generally speaking, for polymer parts. I think this is something that we are still yet to really address properly. I can't say I saw a huge amount of evidence about it on the show, but certainly in the metal space, I feel that this is really progressing very, very well. We did see things like, for example, Stratasys put out with N Frontier, an e-mobility, bike meets car. This again is all about being able to get around in a way that is less carbon intensive. The other thing I noticed, and I'm not sure if you noticed it too, but we tend to have a lot of greenery on the booths. I know that this is a pretty sort of just relatively superficial thing, but it does seem to me to be that a lot of the companies around here are putting a lot of ferns, plants, trees, and so on their booths in order to just even visually appear to care about environmental impact and sustainability. The other thing that we saw a lot of at the show this week, and we were expecting, of course, because there's been a number of press releases leading up to this show, is post-processing. So, of course, you know, additive manufacturing has come out of a prototyping technology. We haven't really been too concerned about post-processing until probably more recent years. I think it was about 2019 where we saw a huge explosion of providers in the post-processing space. Post-processing, of course, is a big umbrella term. It can include a lot of different technologies, anything from heat treating a metal part to inspection to removing support structures. Right? So it's a big area, and it's basically everything that happens once the part is printed. We've had a couple of interesting companies, though, exhibit in the post-processing space, and I wanted to mention them. Rivian Robotics was one of the startup companies that I believe presented on the stage here this week. So it's pretty simple. They have a robot that removes support structures automatically. Now, you wouldn't think that that's necessarily genius, but the thing is that the solutions that are currently out there are relatively inadequate, quite frankly. And what manufacturers are having to do is really rely on some sort of hodgepodge arrangement to try and do their post-processing. Being able to automate those workflows is becoming increasingly important as manufacturers look to scale production and this post-processing element for them becomes a huge pain point. So as a result, we have companies springing up to be able to provide solutions in that space. I think it's interesting that the OEMs aren't taking that upon themselves necessarily to provide post-processing solutions at all. They're really relying on third-party providers. Anyway, there was another company, Solucon. They've exhibited here for a number of years now. One of the exciting things about Solucon is that they, this week, just announced SPR Pathfinder. The beauty of this is that you can get a metal part that, say, is quite complex, has a lot of internal channels, and then be able to automate the powder removal. Now, of course, if you think about producing something very simple, let's say a cup, and you've built that, how are you going to remove the powder? Oh, very easy. You just tip it upside down, shake it about, and then you're done. No problems. But what happens when you're using 3D printing, of course, you're producing these really complex structures, and it's becoming increasingly harder to remove powder from those parts. If we think about a rocket engine, for example, and the things that we can do with additive manufacturing with a rocket engine, but the amount of internal channels that, say, might, in a very simple case, let's say you go up and then down, it's no longer good enough to just turn a part upside down and remove the powder, because, of course, there's still powder entrapped. So what Solucon does is have all of the part geometry within the software, and is able to assess that part geometry and then develop a path, like essentially a toolpath, for how they're going to remove that powder in order to ensure complete removal. So I really liked what they had to offer. They did launch their company with the intention of this product, but now the product is actually available. Post-process and EOS also had an announcement around post-processing, but more particularly around automating the workflow of post-processing. Automation was a huge theme, and to me, automation and post-processing just go hand in hand. You need to have automation connected to your post-processing in order for it to be seamless and much, much less painful. And that's the other thing as well, I should mention, is that software then needs to come in to support that. So you need software to come in and be able to accurately provide that digital twin of your part from the time it is built to the time it leaves your factory. And as much as we all love to think about and talk about 3D printing, the reality is a good 2/3 or more of your part in your factory is concerned with post-processing. It's going to be doing a lot more time doing post-processing, whatever that is and whatever that looks like, and whether it's metals or whether it's polymers, it doesn't matter. But being able to have software that can properly track that process flow is becoming increasingly important. And we're definitely seeing some really interesting software providers out there. Authentize, I believe, is just over there. And has launched now with a number of different partners. Excuse me. And we also have, again, on the startup booth, Magnitude. Matt was here earlier this week presenting. That's around business excellence and operational excellence and optimization, being able to ensure that you're getting the most out of your machine. And again, this is all really oriented towards serial production. So what we're seeing is that the industry is maturing, is definitely moving towards scale. This is something that we've been seeing happen for a number of years now. Like I said, it was about 2019 where we saw this huge deluge of post-processing providers coming and exhibiting at Formnext. And that means that we are heading towards industrialization. And I'm going to talk about investment and why that's really important, but not right now. I'm going to save that for later. The other one was big machines, big builds, big parts. Every time I go and talk to someone who has been at the show all week, and I say, what were some of the resounding themes for you? What are you really noticing as a really big technology move or change or difference? Almost everyone has said big parts, big machines. I thought it was really interesting that we had SLM Solutions, actually during the pandemic, released their NXG 12 laser system. 12 lasers is currently the maximum number of lasers that we have in a metal machine that's commercially available. And it's a phenomenal achievement, being able to put 12 lasers into a machine. Their build volume now, just announced in the last week or so, a collaboration with CTC, an organisation that does development work for the Army. They really wanted to see a much longer, deeper Z-axis. So their NXG now is being extended to 1.5 meters, which is providing a very big build volume. And if you go to the booth, you'll see that they had some beautiful parts on display to showcase that build volume. Another one is E+3D. Interestingly, they're a Chinese provider, so a Chinese-German company. Their build volume is maxing out at nearly 2 meters. So that's a 1.358 by 1.358 by, I believe it's about 1.4 meters. So that's a really big cubic volume, and definitely a competitor to SLM Solutions. They've got 9 lasers in their system. And then, of course, this week, SLM Solutions came in again and announced an even bigger system. So again, this one is much wider in the X and the Y. So I thought that was kind of interesting, because previously they've always tended to scale in the Z, but this is now scaling in the X and the Y. DED is another really big theme, I think, that's coming out in additive generally, and we definitely saw this here this week. An increasing number of DED providers and exhibitors. DED is really interesting to me because so when I say DED, I mean directed energy deposition. So that means that you are consolidating material, usually it can be blown powder, or it could be a wire, with a heat source. And the heat source could be a laser, it could be an arc. And a lot of our DED knowledge really comes out of conventional manufacturing. So welding, for example, is hugely relevant to technologies in the DED space. We have a lot of welding capability, we have a lot of welding knowledge. So to me, it was always very interesting, but also a little confounding as to why we weren't seeing more DED in the market much earlier. What's interesting to me is that laser powder bed fusion has matured over the last 10 years, really, really nicely, and actually quite extraordinarily in terms of the innovations that you see today. But DED tended to lag a lot, and it only in terms of market share was a small amount of the market share. But I think what we're going to see is we're going to see DED increase. And in fact, if you just go down, just down there, just across the hall here, you'll see WAM3D, again, another first-time exhibitor. And they're using a WAM system, so wire and arc, additive manufacturing, and produce a beautiful turnkey solution. And so that's the other thing that we see happening. So for example, with DED, you tend to just jimmy together this, that, and the next thing. You'd have to do that yourself. Being able to provide something that is a turnkey solution makes it eminently more accessible and easier to use, and easier to adopt, quite frankly. I think I did mention I was going to talk about investment. So in 2021, and I know that this isn't necessarily what we're seeing here this week, but we're definitely seeing the impacts of it here this week. And also, we see the impacts of it in the technology space. We can't grow something, we can't mature something, we can't develop something, a technology, if we don't have the investment to support it. So in 2021, we saw a whole host of 3D printing companies list on the public market, usually via what's called a SPAC, Special Purpose Acquisition Company, which otherwise known as a backdoor listing, and being able to raise very large sums of money. There was really this run on SPACs all through 2021, and that's come to a pretty abrupt end as the market conditions and the economic climate has completely changed in 2022. This is having a pretty interesting impact on 3D printing companies. A lot of the companies that you see here today tend to have no more than about 2 years worth of runway in terms of their cash flow. So not going to be able to see themselves outside of 2 years. So having said that, you know, you can always say, oh, you're not going to last, you know, for another 2 years. But of course, you make more sales, you cut more costs, you innovate more, and you live to see another day. I was speaking, though, to the investment banking community a lot this week. And one of the comments that came through was not so much around acquisitions being so popular as they have been in the past, but perhaps more looking around mergers and seeing an increased number of mergers happening. I think that it would be interesting to see what happens in the next 2 years. We really, in terms of 2022, and I mentioned that there was changing economic conditions, have seen a very big shift away from growth opportunities into profitability opportunities. This is making a very big impact. Any of the CEOs that you'll find on any of the booths around here are becoming acutely aware of this issue of profitability. Now, what's the impact on 3D printing? Well, 3D printing is essentially, it's a growth technology. That's why investment bankers are interested in 3D printing, because it's a growth market for them. Growth markets are becoming less popular to invest in these economic conditions, which are looked to continue, by the way, for the next kind of about 3 years. So instead, what we're doing is now much more focusing on profitability. So a lot of the companies in the 3D printing space are very much surviving off the fact that they are growth businesses, not necessarily profitable businesses. And so what we will be seeing, I believe, and have seen this week, but will increasingly see through the course of the next 2 years, is a real increase on profitability. And what does that mean? It means more revenue, of course, but it also means significant cost cutting. And I think that, unfortunately, I mean, I've worked a lot in the R&D space, and it usually means that R&D tends to take a bit of a dive. So companies are much less focused on what they'll be innovating on, and they're a lot more focused on what they're trying to sell. So innovation, I think we might see that tend to sort of plateau a little bit. I know I'm doing show summary at the moment, but I am also doing a few forward-looking statements, and I hope that that's okay. But back to the show, I think the other thing that we really saw come through pretty strongly is this post-pandemic world, if I can call it that. I see Sasha over there. I had a meeting with him just this week, and he made a beautiful statement. He said, the AM community is a hugging community, which I thought was a lovely thing to say, and it's certainly my experience. Hugs are back in fashion, I guess. And on the first day when I came into the show, someone said to me, Alex, how many hugs do you think you're going to be giving out this week? So there was a lot of hugs going on, which was lovely. We are definitely a community, and this is our opportunity. This show, Formnext, is our opportunity to all come together. And it's lovely to see everyone. The other thing about the show this week is that the Formnext show is now back to pretty much pre-pandemic levels. So getting very close in terms of floor space and numbers of exhibitors to what they were in 2019. However, so just pretty close to 2019, but we are missing all of our Chinese exhibitors, and we are missing all of our Russian exhibitors for reasons that I'm sure you're all aware of. But if we had Russian and Chinese exhibitors here, you would see an increase on your 2019 numbers. So it's safe to say that we are back into full swing. I was really lucky to go and see a fantastic presentation by a guy called Chris Connery, who works for Context World. Context World gets data from all around the world on shipment, mainly on their shipments of printers. Okay, so their shipment data is incredible. But what they've been able to do is calculate that through to revenue. So Chris put up a number of different slides at the TCT conference and talked about all the shipments that we're seeing in the last number of quarters from 2019 to now, And what we saw is a 40% increase in total revenue in the 3D printing industry. 40% growth from 2019, and 56% of that was from industrial machines. And of the 56%, it's metal AM that's really driving the growth. And I mentioned DED and laser powder bed fusion. That mix is changing slightly. So we're seeing that while laser powder bed fusion is certainly growing in revenue and in market size, it's growing in line with the rest of the market growth of 3D printing in total, but its total share of the market is decreasing. Interesting data point, I think. Finally, Formnext is a wonderful time, like I said, to be coming together and to have great parties. So we had the Formnext party last night, which was a huge celebration. And again, I think, like I said, this is really looking to 3D printing being in the post-pandemic world. So it's lovely to see that we can get together and celebrate in this way. It's my thanks go to Masago for putting on such an incredible show. This really is the world's premier 3D printing event. And what I think is interesting is that despite the fact that we've got shows of various different guises in 3D printing all around the world, Formnext remains the #1 show to get to every single year for anyone in the 3D printing industry. So on that note, thank you very much, and I hope you all have a wonderful rest of your day and safe travels home.
Thank you so much,
Thank
Alex.
you, Sven.
Big applause, please. Alex, let me start with a compliment, if I'm allowed to, because, I mean, as you started your speech with, you apologized for your voice, because we are all kind of exhausted. You just mentioned the parties at the very end.
Yeah.
We all have been yesterday at this wonderful, big, large party, and we kicked off with Dimension. So we had, beside the exhibition, we had some, let's call it, in a positive way, stressful hours behind us. So, coming back to my compliment, after 4 days, full impact, and I can imagine in your role and what you presented to us, you had like tons of conversations, speeches, etc. behind you. This was so inspiring, was so much fun to listen to you. And you did something great to me, because as I was moderating all time here over the 4 days, I hadn't had the chance to, no, that was not that was not fishing for compliment, by the way. I just wanted to say, I never had the chance to went out and visit the exhibitors, and you gave me a perfect overview over the whole exhibition. Thank you for that. But let me ask some critical question, if I'm allowed to. Starting with sustainability, you mentioned. I remember last year I talked to Sherry as well at AMGTA, and she was telling me how difficult it is to do these LCAs. I heard this very often during the speeches we had here or panel discussions. How do you see these LCA trends? Is it realistic? Is it true? Don't get me wrong. Are all these LCAs true? Are they considering everything that needs to be considered? How was it for you, and what was your perception on all these LCA?
Yeah, well, I gave you a small clap, by the way, because being here for 4 days and moderating on the stage, that's a phenomenal job. So well done to you, because you're nearly at the end of your week here. An LCA, it's a life cycle assessment. Now, the issue is that too often we might do an LCA study and pick and choose what part of the life cycle gets assessed, and that's not the correct way to do a life cycle assessment. When I spoke to Metal Powder Works, and I mentioned that they said, oh, well, you know, we had a life cycle assessment done, and our process is 90%, you know, less carbon footprint than conventional powder manufacturing. And my first question was, oh, did you do that yourself, or did you get someone else to do that for you? And they said, no, you know, we got someone else to do that for us. They're a well-known and recognized outfit that do life cycle assessments. So, I mean, of course, if you're paying someone to do a life cycle assessment, there's always a small conflict there. But having said that, really the provider, if they have any integrity, you know, and that's where reputation becomes so important, right, is going to do a very truthful and very honest assessment and do a life cycle assessment. So it really has to be from beginning to end. And when I say end, it's not when the part leaves the factory, for example. It's when that part sees the end of its life. So very important. And I mean, again, I talked about 6K. They're doing a life cycle assessment with Fraunhofer. I mean, Fraunhofer is an incredibly well-respected institution. And so I think that forming those sorts of partnerships, doing the life cycle assessment with a very reputable provider is very important. And back to Metal Powder Works, one of the comments that was made was they looked at another part of what they were doing, and they asked this same provider to do a life cycle assessment, and they said, we actually felt that the results were a little bit too good to be true, and we asked them to go back and have another comb through, because we were concerned that they were missing data that they shouldn't have been, they hadn't captured. And I thought that was a really good comment, actually. Sometimes you can get that sustainability story that's a bit too good to be true. So yeah, the AMGTA play a really important role in being able to facilitate these studies and ensure that there is integrity in the process. And one of the things I mentioned to Sherry was it would be really nice if the AMGTA could put out something like a handbook just to explain, what a life cycle assessment is, what's the correct methodology, and really how you should be putting that study together. So.
Probably already on their agenda. They're not that old, so probably coming next. Another interesting topic, and we discussed it several times, and you combine two things, and I found that very interesting. We were talking about the topic of post-processing and automation, that this was a big topic here on the exhibition. Then you tackled the topic of investments and how that is changing now from focus on growth companies to more probability and realization of revenues, etc. And it is interesting because we discuss so often this topic of automation. Would that be not rather a positive trend to put more focus on probability and creating revenues, but this would force the companies to put more focus on more automation and more post-processing? Would that not be a very good, let's put it,
outcome.
Yeah, co-outcome. That would be much better because, I mean, we are talking, because you mentioned R&D and we're talking all the time about innovation trends, but at a certain time you need to streamline things and get things better. Don't get me wrong. I mean, put focus on the process and be more economic scaled and not only innovation scaled. So how do you see that?
Yeah, no, I think that's a really good point. And actually one of the things I meant to mention was what we're seeing a lot more is customer testimonials. And so you've got, generally speaking, you'll have a press release about something, and then you'll have that company says, for example, we're releasing a new machine, and then they'll say, they'll have a quote in there from one of their customers, say one of their, their beta testers that says, we've been using this and this is what we're using it for, and this is why it's really important or helpful for us in our business. The reason I mention this is because we were talking about growth versus profitability, and I think that this increasing drive towards profitability, what's coming out of that is things like customer testimonials. So it's no longer, it used to be, it was just like, let's launch a machine, out. Push it out. But now,
no matter what kind of application is behind it.
Yeah, exactly. But now I think a lot of the OEMs are now doing a very hard pivot on that idea and doing, in fact, the reverse. So really holding off on launching a machine. HP's Metaljet was in development for a number of years, with their beta testers and customers. So, but again, sorry, back to the post-processing. Yep, no, you're absolutely correct. We've got, we've always been, I think we've been talking about it for a couple of years around, serial production and so on in AM. But I think with the change in market conditions now and this increased focus on profitability, we are going to really see a shift and a trend towards production because, companies here now are being assessed compared to other much more profitable companies, but from investment bankers. They're now being put on the same playing field, essentially. So, yeah, as much as we're an emerging technology, it's very much time to be pushed towards being much more commercial.
Absolutely. And as I'm more from the commercial part, I would say this is probably the more sustainable way of developing our industry.
Correct.
Instead of just focusing on new innovation, new technologies, etc.
Yeah, and the other thing I think as well is customer-funded development, right? So rather than raising money and spending that money on innovation, it's going to be much more around, oh, hello, customer A, you said you really wanted a machine that can do X, Y, and Z. Let's put a program together where you fund that development, and we will strike some deal around the outcome of that. So I think that we will see a lot more of that, and that's a really good thing. We should be having products developed that are being informed by the end users.
Market-oriented, not the other way around.
Yeah.
So we're running out of time. I could tell you, Alex, we can keep on talking. Let's skip to the next point. No, I'm sorry, I can't do that. Thank you so much for being our guest. It was impressive. I learned a lot, and that's the main thing. Thank you so much, and good luck for the future. Okay, see you next time. Okay?
You too, Sven. Thank you so much.
Thank you.
Bye-bye.
Alex Kingsbury, ladies and gentlemen. Yeah, ladies and gentlemen, let me be honest, okay? The following announcement is naturally the hardest for me, because we are slowly coming to the end of Formnext 2022. The nice thing from my side is that it's not the end, actually, because in a moment I will be visiting my colleague Frank Jablonski in the afterwork talk, and we will be welcoming two very important guest at the last highlight, and you should not miss that. Before that, we have another highlight block for you. Please do not miss the next show. 4 minutes to go. See you there.
Luke, thank you for joining us, Head of Sales and Innovation at Curb. You have joined forces with Formnext this year and organized the Permundus Challenge. Tell us about the Permundus Challenge.
The Permundus Challenge is a design contest for additively manufactured products.
And the last 10 years have been a journey for additive manufacturing.
Oh, definitely.
Yeah.
Definitely they have. And that's what this retrospective view of the different winners of the last 10 years really show. That there is a development and that it has come to real manufacturing, to real useful products.
And how have you seen additive manufacturing progress over these past 10 years?
Well, generally a lot, but people look as well as the applications as how to combine material and process, as how to make a really good design, and because at the end it's a design contest.
What are the developments in the business models of these companies? Like you said, small SMEs, big companies, they've all won Permundus Challenge at some point.
Yeah, there are students with ideas. Some of these ideas will go into startups, and we are happy as CIRP, as a service provider, that we could help some of them really producing their products.
And what are the expectations? I mean, the past 10 winners, what do they bring to the community of additive manufacturing?
Oh, well, that's a difficult question, and we had several winners every year, but I think it always has been a view into the future, and the future has come true for many things. So especially for people with special needs, you see quite a number of good samples how you can how you can assist people with special needs. And I believe that has become true over the last 10 years, and very good samples have been winners of the Permundus Challenge.
Very nice. Mr. Luke, thank you for your encouraging words really regarding the industry and how it's grown. And I thank you for your time, and thank you for showing us around. And we are excited to be here when the champagne bottles pop.
Thank you.
Yeah, thank you for your time.
So Mobility Goes Additive has its premises in Berlin, which is the capital of additive manufacturing, and therefore we need a lot of contacts. Here we can meet all of our members, and we also meet a lot of users, which might not have booths, but we have them in talks, and the quality level is very high.
Boeing is always looking to onboard the latest technologies. Anything that adds value to Boeing business cases, to Boeing products, right? So we want to see what the latest developments are and really to stay on top of that. And Formnext, I think, is fair to say, has it all.
For us, Formnext is so important to be here because we have outreach to the whole world. We are a scale-up and we see so many decision makers over here. There's no other place than this to challenge the vision and make it work.
Yeah, so of course Formnext, I mean, that's the big event for us in the year. So everything that we do when it comes to product launches is always around, we always plan it to launch at Formnext. So of course this is very important for us.
Formnext is so important to AM Ventures because everyone is here. This is where the decision makers from all over the world are gathering 1 week per year in Frankfurt. This is where you have to be if you want to do something, if you want to build a business in our industry. This is where you have to be.
Welcome to Formnext 2022, last session for this year. But I'm more than glad to have some really nice guests here. I'm looking in glad but exhausted faces, I think. I'm very happy to have you here for our after-work talks. Petra Harburger, President of Mesago, and Sascha Wenzler, he's Vice President of Formnext, and Sven Krause, everybody knows him here on stage, my co-host here on stage. Yeah, now, Formnext is over. Can you believe it? It seems like minutes, seconds ago, when I stepped into this hall with the colleagues on Sunday. We came here on Sunday to prepare everything, and had tons of cables and everything, and now it's over? I can't believe it.
Yeah, I guess this is this phenomenon of doing exhibitions, You go in the day before it starts and you think like, wow. And you're so excited about it. And then it's like bing, 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 and it's over, yeah. I always compare it to somebody cooking a really great meal, and then everybody's sitting down at the table and within 10 minutes or half an hour, everything's gone. Yeah, no, but it was wonderful. As you said, I think just look at us. I think we just said you can see in our faces that actually it was not only long days, but long nights as well. Yeah, but so, this is also part of it.
This morning when I started my presentation or moderation, here my voice was a bit, a bit behind. Yeah. My voice was still in the yesterday.
Yeah. My voice today is even more still in yesterday because it has not recovered. But yeah, that's a nice comparison with cooking the meal, and especially for me and for us. We have such a wonderful team, and this team cooks very hard all over the year to make these days happen. And yeah, then they start, and you start with a shiver, and you finish with a shiver, because it's it's this magic atmosphere created with such an event, and it's only possible with the team. So also here on this stage, thank you to the whole team.
We call them phone fighters.
The phone fighters are the best ones. The additive manufacturing community is the best community. So it's overwhelming. It's always overwhelming opening this show and finishing the show.
But give me some insights about your feeling. Let's do it a bit on a time scale. What was your feeling when you came in here? I don't know, when you were here Saturday, Sunday, Monday. When was the days when you came in here, and what were you feeling? Were you anxious, or what was in your heart?
It's a bit crazy because, frankly spoken, the Formnext team has the office here on the fairground, so we are here every day. It's like you're living here.
So that's not a real thing.
It's not, you know, we're really at home here. So we can see the halls from our office. We can directly look at hall number 11 and 12. And yeah, we work on it. We work to make it happen. And then last week, you know, the first big emotions, the first excitement started when the trucks came in.
Yeah.
Because all over the year, you know, you look on an empty space, or
you have a number. How many trucks are coming in? I think there are some numbers.
It's hundreds.
Hundreds
of trucks coming in. So it's not empty because other shows take place. But for us, it's empty because it's not our shows being built up, or Formnext being built up. But then our trucks came in, and I just made the first pictures of them and made social media posts.
You made a picture of the empty hall.
Yeah,
I saw that
and
one.
I remember that one, Sasha. When I read this on LinkedIn, I was like, wow, they haven't even started preparing.
It's quite something that, maybe it's starting soon.
That was the day before the first truck came in, and then they came. And then you know, it's like a train, you know, a train starting. And suddenly this train has this speed where it will not stop until today.
When I came here into that hall, you know, all the mechanics were working, the woodworkers, and that's very impressive for me, because, you know, everybody at the booth, they just have their own area, and they were working. Some were cooperating, but most of them are doing their business. And it's quite, somebody has to do a film on that, especially just on these guys who prepare the booth. So it's incredible work what they are preparing here. The neighbor booth, they prepared a roof. You know, it's a total roof they built here, and you could use it at home. I don't know, in your garden or something. It's quite artificial work, and they built it from scratch. It's not brought here and combined or something, or assemble it. It's made actually on Sunday before the exhibition starts. That's very impressive for me.
You know what my really most impressive moment was over the 4 days? Remembering when we had France Additive here on stage and we're talking to them, and he was talking about his first encounters on the fair, and then he told the story that he was looking for something for his private house, and he found it. He found it here at Formnext. I was like, wow, we're talking about innovation, trends, and all that stuff, and about national plans. And he was like, yeah, I got a problem solved with my house here at Formnext.
Can you remember what it was? It was something through the roof, or
like a light
bulb, or something like that? I don't know. I can't remember, but I know that I was very impressed as well.
Like, yo, okay.
Because I thought when we both are asking a question like this, we think it's okay. It's for the company or for some technical reasons, and it's very useful for the private area as well. Unfortunately, you were a bit more on the fairground underway. I was very much stuck here at the back office. So unfortunately, I have not but I don't have a summer house in France. So I don't know what to do with a light bulb. I would put it under my bed,
But one question I do have, Sascha, Petra, we met Christoph from time to time, who's part of your team, and how are the days for you? I mean, you're organizing the whole year, then it's there, then what do? You have you have to talk to clients, you have to have meetings all day long, you have to prepare. Sascha, I know you prepared the party, or you were responsible for the party.
It's like this, when the show starts, we have a special office somewhere here, we go in, and then we're done for the rest of the 4 days. And now we came out just 5
Yeah,
minutes
right.
ago.
Okay. Just sit there all the
and we
time.
come back and say hello. No, yeah, just kidding. No, it's like for all the same for everybody here. We started, and we already started on Monday with the Standards Forum, with the ASTM Standards Forum, doing the opening there, and opening the form next week. And then it's really 24 meeting business, maybe a couple of hours sleep in between, and a lot of already strategic thinking about new corporations, what's going on next year, what are the highlights, what were the main topics here also for the companies, for the exhibitors, for the user industries, what do they discuss, where are the trends? That's highly important for us to stay up to date.
Sasha, would you please do me a favor? I know we had a in-depth talking about the different industry sectors and the maturity of these. Can you give us some insights how they developed right this year, and from the lots of discussions and meetings you had, is there progress or more progress in one or the other, in the one or the other?
For sure. So it's not only a larger variety of technologies. It's not only launching new machines.
Exactly.
It's much more still a maturation of becoming mature technology, a mature manufacturing technology, with all the questions related to this, which means also the companies, they don't see themselves solely as a machine provider, as only a machine manufacturer selling a machine. They develop to solution providers for their customers.
We had exactly that point today on stage.
Yeah. And that's definitely one of the highlights developing over the last years, but especially this year, this was one of the main topics. Machine-to-machine communication, very relevant, became very relevant when you talk about an automated, digitalized factory environment.
And it not only became relevant, but the VDMA, they are here and they are really working on it. And it's not like this that, okay, additive manufacturing is still behind, we can look at them in some years. They are today or yesterday, they have been working on it, like it's a OPC-UA connectivity,
exactly.
Zuumati standard.
Yep.
So
exactly.
it's becoming
just one sentence more about the highlights, because we are all excited about the highlights. It's also the customers asking very precise questions.
Yeah.
And questions about the manufacturing process, and not any more questions about can I print this or this product. And that's also a different.
Petra.
Oh, that was just what I wanted to say, but he just said that. We just had really good feedback today, also because we asked the customers or the exhibitors, how do you see, or what was your perception of this year or the change? And I think most of them really said that people were coming with concrete, really specific solutions, or not the questions about how to solve a problem. So they already had something in mind, so you wouldn't have to teach them anymore anything about, so they really asked for specific things. So you really go deep down into solutions already, and no longer, explaining what additive manufacturing is about. And I think this really, everybody told me that, and this is this typical sign of having more mature industrial production-like things. I think one of our advisory board members, he had this very funny thing. He said, like, it's now getting manufacturing boring. So, so, it's about this hype really going away a little bit, that, where you think you can do everything, you can print everything, and now they really get down to reality, but in a positive way, that things really are now happening and no longer dreams, but really being integrated into production. So he had this saying that it's getting a little more boring now.
Another saying today here, I think it was meant in the same direction. I don't want to have any hypes anymore. That is he meant the same, I think. Just we are doing it. So we are doing it, and we deliver. We are delivering.
That was Daniel from Stratasys this morning. I want to totally agree. I mean, the two of us are accompanying this quite a while now. And the funny thing is, what I really liked about this Formnext, and you might call it manufacturing boring, but on the other side, considering it in a positive way, is that we start to do like a kind of self-assessment. Are we doing the things right? We are doing it, and like Alex mentioned, the bringing more the customer, the end customer perspective into the game. It's you know, I mean, all of us celebrate at additive manufacturing every year, and we are so great. But I like the fact that we get closer to a realistic approach to sort, like Daniel said, 0.01% of manufacturing. You know, but on the other side, solving much bigger problems. But the right way, and like automation, post-processing, being more cost-effective. Those were the trends I experienced over the days, and honestly, I highly appreciate that because it's getting more serious. We are getting more realistic. That's a good way, in my opinion.
That's exactly.
But I like the mixture because I had a very. I found it fancy. I hope I don't offend anyone. They were talking about AME. Additive manufacturing electronics, and that's really not a topic you can buy today, an additive manufactured electronic part, but they are working on it, and it's from an institute, you know. It's, I think, when I remember right, it's Fraunhofer Institute, and I found it so much interesting that they are working again on the next step, and a really next step, and the next step, and maybe next year, 2 years, 3 years, we have some printers here that can print a circuit board, and that's very fascinating.
Yeah, and it's still about pushing the border further of AM.
And some years ago, you just had the fancy ones. And now you have the mature, it's working, they are delivering, and you have the fancy ones in the next steps and widening the area of use.
Yeah, and still it's a very good combination, a lot of exchange going on also between the companies. That's also, I think, what's still very special for the additive manufacturing community. They are not closed to each other. They still have this spirit of driving the technology, of talking to each other also about the problems, about the challenges and how to solve it. And it's not this being like in a nutshell and very competitive to the other companies in the market.
It's always interesting because usually here the Friday is more of this day where they visit each other, because we have a little less visitors usually on the last day, which is normal, but that for them it's good, because they said, some of them, I just was at one, he said, during those 4 days, I didn't even see anything because I had no time. There were people on my booth all the time. He said, I just had to go outside sometime for some fresh air, but that was it. So for them, it's also good that today they are also able to see something, And he said, like, wow, hopefully I'm able to visit one or the other of my friends. Some of them are really friends. They know each other for a long time. So I think this family thing they even have within them, within the different companies.
That's one aspect, friendship, but there's another aspect. They are customers under each other, because we have the whole process chain here, and when he goes to the next hall, then he will find his provider or his customer. So that's, I find, too very interesting.
It is. Definitely.
Very connected industry.
And Petra, you just touched a little bit the visitors and the visitor numbers today. So that's also for us. It's always this moment after the show to also look at the visitors and the numbers of visitors. And also here we are overwhelmed. So we can count. So it's still going on, the official count, because the show has not closed. But we range more or less or we will end more or less with 30,000 visitors.
Wow.
So that's incredible.
Yeah.
It reflects also, I just said it yesterday when the party was opened, the additive world came back to Frankfurt. It is in Frankfurt, it was here in Frankfurt the last 4 days. Formnext is their home base, and it perfectly fits to these 802 companies. A little bit looking back in 19 with 852 companies and 34,000 visitors. Last year 606 companies and around about 17,800 visitors, and this year the 802 companies and the 30,000 visitors with a high internationality.
I
Also
suggest watching the recorded visitor voices we had, and there were some people saying, you know, that's a point to be internationally when you want to learn about AM. So, and it's not my saying; I'm just citing it. It's what the people say. But I want to change the focus or widen the focus a little bit. Did you already have an invitation sent to Ursula von der Leyen?
No, not yet.
Oh, well, let me check the mobile phone.
You didn't hear about. We invited Ursula von der Leyen. We need her here because you know, we are a very much international community, and we had guys here. They discussed, okay, well, there is in US there are programs. We had French guys on Wednesday that said we have programs in France as well to enhance additive manufacturing, and we had the guy from VDMA here who said, okay, we are doing a lot, but we could do more in Germany, and the conclusion was that we have to have a European program to get this market here, you know, a bit more fast forward. And
yeah, that's a good point.
The best guy to be here would be Ursula von der Leyen.
And maybe, you know, we can make it a little bit more attractive, the invitation, because we
invite her to the party.
Yeah, we invite her to the party, so everybody attending yesterday still has also the same voice, not only talking here all over the day, but through the night as well. But we quite had some political prominence here, in fact. So we had a Consul General from the US, we had a Deputy State Secretary from the US, we had a Consul from Turkey, from Switzerland, and the lady Consul General from France.
Yeah.
So maybe this attendance also shows how the importance of Formnext rose also in the political level.
But this is a topic I want to strive a little bit. This was the first year where I really early started to getting connected with Formnext. You know why? Because what is always under the surface is your work before Formnext. Because people see these 4 days, and when I speak to the ones you met just one time a year at Frankfurt, they're all celebrating Formnext. We're back again, most important moment in the year. And absolutely cross in the box, it's perfect. On the other side, I saw you traveling a lot. You are having these other Formnext formats all over the world. You're visiting clients. You're digging into the industry. You're getting expert talks all over the year. How much work there has to be done in order to prepare this program? Because this is, I mean, Frank and I experienced it when we start preparing. We had to learn a lot. We have to look for words and expressions for technologies to understand that. You're doing this all year long, otherwise this program wouldn't be feasible.
And actually, you know, it's not only, it's our approach, because, you know, we want to drive the industry through our platforms. So this is the culmination, let's put it like that, during the year where everybody really comes together. But we have a lot more different touch points with them, because I think for them as well, it's not only happening in 4 days here. So they have business, they have to prepare for this, but they are running their businesses. So we also see each other here, or the team, or us as Metago, as an enabler also for them to make it happen. And I think this is a lot more, as you just said, than the 4 days, although this is like the climax, but everything pays on that, yeah? You just said that. We visit also different forums, different events that they do, but also we create different events for them besides the show, because there's also other business they do, which is not only happening here. Yeah, so I think this is something we focus on that, yeah, because we think it's important for them and for us to be the enabler for them throughout the year and not only for the 4 days.
Yeah, it's for us. From the very first beginning, it was highly important to become, and now we are part of the community.
Yeah.
And that's only possible when you dig in the technology, in the market, in the trends, in the needs, and it's the same for you guys. Additive manufacturing luckily makes it easy to become an additive addict.
The community makes it easy to
and the
become
community makes it
addicted.
easy. So I think it's a win-win situation for all parties involved.
Okay. I do a bit of crasher of the good mood here
It's
at
good.
stage.
Crash
Yeah?
us.
So no, life is not always easy. So there are some hurdles to take. What was not so good, and what do we do? That is not so good. Huh? Just on time.
And, very unplanned certainties.
Yeah.
Give me some seconds to think.
So enjoy that, because I enjoyed it every day.
Yeah.
Because
Yeah,
usually I was
right.
not on stage.
Yeah, true. Very true. No, I think.
Wait.
Yeah, okay, we wait. And I think about what I want to say, then maybe that's so. Yeah. Yeah. Now comes the English one.
But this is a really nice voice. Who's
Yeah.
that? We know her?
Oh, nice colleague, for
Yeah, it's
sure.
one of our team.
Sven, nice colleague for sure.
That was
We collected the timetable of these just to make sure that we do not get them in the live stream, but we failed. We failed.
Yeah, but it was perfectly timed
that
for
was
your
good.
question.
Yeah,
it was
exactly.
perfect time.
Because every day before the show, during
It's
the
like
show,
Murphy's
something
Law.
can happen.
Yeah.
and that's really always one of the challenges. And all of us were affected this year by geopolitical catastrophes taking place, like the Ukraine war. We have the inflation
The energy
rising. We have an energy price rally combined with maybe an energy crisis. We have still the climate
is it
change.
a topic for you as well? So are you dealing with cooling down the temperature here, or shutting down the light or something?
Yeah, definitely. So it's not recognizable, but we dimmed the light, for example. That's an active measure to go down with the energy consumption. We had a shortage of wood. We had a for construction wood for the stands. We had a shortage of paper. So all of us have a lack of colleagues, of human resources. A lot of people behind the scenes, over the pandemic, they went to different jobs and they did not return in this business. So also here a big thank you to all of the organization behind, because they made this happen in much harder circumstances.
You have Chinese colleagues as well. I met her.
Yes.
And you told me a story about what is a business doing in China. Will you share with us?
Well, I think
you know the story I mean? You coming into China and have your meeting, and you have to leave again on the same day.
Not being able
to go to the hotel, otherwise you would have stick there for, I don't know, 10 days or something.
No, I think they reduced the quarantine now, but I think this is exactly it, and it's so hard for our colleagues and everybody there, because I think it's not what they love to do, but you're sort of bound to that.
okay, these are hurdles. You are a clever guy, I know. We cannot change. But what is your perspective for next year's? What can we do better? What is there to achieve? And you have the audience here at the booth. You have the audience outside in the live stream. That's a chance to say to them, okay, we are heading there. We want to do something better. We are wanting, fast forward in that direction. What is it? What can we do better? Where is Formnext 2023 next year? We had some joke, Sven and I, about the
right
year.
The right year, right?
It was quite difficult.
You always think careful when you're talking about are we 2020, 2021, 2022, 2023. So what can we achieve next year? What we did not have this year?
Yeah, we can...
Nothing. Petra says there's nothing.
No,
everything is perfect. How nice is that?
Yes, but for sure the AM world will be here again. We will have this wonderful show here again. But what we already did is think about which will be the highlights we can put a spotlight on.
Are there new highlights next year?
Are there new highlights? Are there new topics becoming more and more relevant? And yes. And I'm sure you also experienced this in your talks here on the stage. So one of the things we already know is we will put a spotlight, a highlight on the topic of sustainability, and to bring in more clearance about this topic, talk about more life cycle assessment and orientated discussion, about a more holistic discussion. And I think that's a point not only relevant for next year, but ongoing. It will stay relevant, and it will become one of the very big points in AM.
Okay, I take this one. I would say just more exhibitors and more visitors would be my answer. But if you want to stay with the amount of visitors and exhibitors, for me it's fine.
We're the content guys.
Yeah.
We're the content guys.
See. I mentioned earlier here on stage, I don't know, yes, it's all mixing up in my head. I think it was on Tuesday I mentioned we have to bring all the machinery industry here, which is not contributing to AM. They should exhibit here their products, and then we bring let's say the old machinery and the new machinery together, so that they have 4 days, to get new business done, and maybe that would be a good business model for you as well.
And it's not old and new machinery. It's it's when we
very
talk
important.
You're right.
Yes, absolutely.
Traditional. All this is wrong with traditional machinery.
It's amending technologies, and when you talk about the process chain of manufacturing, you have different types of technologies, of machines, of software, of hardware, connecting it. And this will definitely also be one of the points to increase the parts necessary to fill this process with technology, because that's when the customer comes and asks for a solution. That's exactly the answer. The answer is a manufacturing process, and here is the show floor to see this.
Yeah, I take this as the last word. Do you want to say something to the audience? Because otherwise I would say something to the audience, because I want to say a big, big thank you. A big, big thank you to you 3 guys here with me on stage. I'm so lucky to be with you this week and the days before. And to you, dear audience here at our booth, that you have been here the whole time and listening to what we are doing here on stage. And to you, dear audience outside at the screens, we are very happy to have you had. You know that you can watch everything in the Formnext Mediathek. You can watch all the recordings afterwards. If you missed the one or the other topic we mentioned here, then you have the chance to look at the recordings. And now I want to say a big, big thank you to the team behind the scenes, to the back office. And I would like to get everybody here on stage, that you outside see who is working on that. Sven, come with me. Yeah, the people working here in the back office. there's so many people working to get this one happen. We do not have all of them here. It's just a tiny amount of men and women. But you know, that's these one. They are here, and Sven, unfortunately, we have to send some of them away again. Sorry for that. That's not a joke, because otherwise the live stream would not work. But let's clink the glasses, and when they have the glasses, we have to send them away. You know, because in the back office, otherwise we would send the whole day, the whole night, and everything would, you know, be rumble. 2022, and welcome to
Cheers.
the AM4U
Cheers.
stage.
Great show. Thank you so much.
So you guys, sorry, but you have to
Yes,
leave again.
yes,
Otherwise,
yes.
I have to
Yes.
talk about the whole day and the whole weekend.
Cheers.
Cheers. I'm so glad to have you all here, and many thanks to all of you. And that is the team, or part of the team, that made it happen, that we are here, and we are so thankful for it. Thank you very much. And that was Formnext 2022.
Thank you, Frank Bonski. It was a pleasure to work with you. And thank you, the audience, for the big show, for your interest. And see you next year in 2023. Cheers, mate. Auf dich, Frank.
Auf uns.
Wer hat diese Idee gehabt? You fucking
You fucking
joyride, a hit and run. I thought I loved you and you thought I was fun. I'm moving on down the road. Watch me as I go, watch me as I go. Should I look both ways before you cross me, baby? 'Cause I don't break for boys. I'm moving on. For miles, 67 fastback, oh, it's just my style. We're headed down the road. Just enjoy the show, watch me as I go. Should've looked both ways before you cross me, baby, 'cause I don't break for boys. I'm moving on.